Good morning, everyone, and welcome to day 2. We have a great lineup of presentations on onions today and lots of layers to peel back. We start with the first presenter, Julia Scicluna, technician at Muck Research Station. She's talking about the Stemphylium on onions.
Hi, everyone. Today, I'm going to talk about our research trials that we've done to try to better manage Stemphylium on onions. So I'm sure all of you have seen Stemphylium in your fields before and are pretty familiar with this. So I'll make this quick. Essentially, Stemphylium leaf blight is caused by the fungal pathogen Stemphylium vesicarium. We first started seeing this in Ontario in the Holland Marsh in 2008. But since then, this has become the most common foliar disease that we see on onions year after year. So usually we start seeing symptoms of the disease around the beginning of June. And then we don't really see the disease really start to become severe until later in July, and into August is when we see the most severe leaf dieback. So the biggest problem with this disease is that the leaf dieback occurs prematurely, and this can limit the uptake of the sprout inhibitor malic hydrazide. So I'll just quickly go over the life cycle of the pathogen. So essentially, it overwinters on dead onion leaves, and then in the spring, once it starts to rain, spores are released, and these go on to infect the onions and cause symptoms, which then produces more spores, and then we see more infection of the onion leaves, and we start to see the disease spread throughout the field. Then at the end of the season, when the onions lodge and the leaves die back, the pathogen can again overwinter. So we've seen a range of disease severity for Stemphylium since we started tracking this 10 to 15 years ago. Luckily, a lot of years we do see low to moderate disease severity, but there are some years like 2015 and 2023 where we see high disease severity. And last year we saw moderate to high severity. So usually for Stemphylium, we're applying fungicides beginning at the 3rd to 4th true leaf stage, which is usually around late June. And then these applications continue until the beginning of August. So one of the problems is that, I'm sure you all know this, but only 7 products are registered for Stemphylium on onion. So this is Quadris Top, Luna Tranquility, Circadus, Aprovia or Aprovia Top, Miravis Duo, Maravon, and Allegro. So one of the challenges is that of these products, 5 of them contain one group 7 active ingredient. So this makes it really difficult to rotate between the frac groups to prevent the development of resistance. And unfortunately, we have seen some resistance develop. So the IPM program doesn't recommend Quadris Top or Luna Tranquility anymore due to high levels of resistance. So this makes it even more difficult to rotate with the group 7 fungicides because Quadris Top was a group 11 and 3. So that leaves Allegro as the only fungicide that's registered for Stemphylium, which doesn't have a group 7 active. So I'm going to talk a little bit about our fungicide efficacy trials for the last 2 years. So in these trials, we are looking at some products that are registered for Stemphylium. So that's Miravis Duo, Circadus, Maravon, and Allegro. And then we're also looking at some products like Sevia and Diethane that are registered for other onion diseases like botrytis, but aren't necessarily registered for Stemphylium. And then a couple biologicals like T77 and Serafel, which aren't currently registered on onion. And one thing to note is that these products do have different application intervals that range from 7 to 14 days. So in 2023, we were looking at a few registered products and some biologicals, as well as Sevia and Diethane. So unfortunately, we did not see any reduction in severity compared to the check. But we did see that Miravis Duo was slightly better than at reducing Stemphylium than Diethane, Circadus, and Sevia alternated with T77 and Diethane. So one thing to note is that the systemic products like Miravis Duo and Circadus were applied at a 10 to 14 day interval in this trial, and we did see a high disease severity with a DSI of around 80, which could have prevented some fungicide efficacy. There was another trial on the station in 2023, which included Allegro, which wasn't in the other trial. So in this trial, the fungicides were applied at a 7-day interval, and we do see more of a difference here. So we see that Allegro provided the most suppression of Stemphylium, but we also see that Miravis Duo also suppressed Stemphylium compared to the control. So in 2024, we had a similar trial looking at Allegro, Miravis Duo alternated with Allegro, Miravis Duo on its own, then Fulpan and Circadus. So similar to 2023, we see that Allegro and then also Miravis Duo alternated with Allegro provided some suppression of Stemphylium, but we see less of a reduction in disease with Miravis Duo alone this year. And then we don't see any reduction with Fulpan and Circadus. So one thing that can lead to a lack of fungicide efficacy is fungicide resistance, which we are seeing develop in the Stemphylium population to quite a few active ingredients. So usually fungicide resistance develops when fungicides with the same mode of action or FRAC group are applied continuously without them being rotated, or just applying these fungicides often can lead to resistance. So unfortunately, Stemphylium does have a high risk of developing resistance because it has a short life cycle and it produces a lot of spores. But the fungicides that are registered for Stemphylium also have different levels of resistance risk. So rotating these is something you can do to help manage the development of resistance. So usually the group 11 fungicides like Quadristop are at a high risk of developing resistance, while the group 3 and group 7 products, which includes Miravis Duo, are at a moderate risk, while the multi-sites like group M or group 29 like Allegro are at a low risk of developing resistance. So this slide is just showing the level of resistance to some of the common products and active ingredients since we've last assessed them. So the last time we assessed oxoxystrobin, which is in Quadristop in 2023, we've seen that all of the samples we've collected have been resistant to this active ingredient and all the others in the group 11 fungicides. So we aren't really seeing any efficacy with those products anymore. We did see low levels of resistance to difenoconazole, but that hasn't been assessed since 2019, so that's something to keep in mind. Then for Lunar Tranquility, we have the group 7 fluopyrim and group 9 pyromethanol. And here we're seeing that when these were last assessed in 2019, there was consistently about 30% of the samples being resistant to fluopyrim and about 50% being resistant to pyromethanol. So the last two fungicides, Miravon and Circadus, both share the group 7 active fluxiperoxide. So we've last assessed these in 2023, and we're seeing that about 60% of the isolates are resistant to the FRAC group 7 product. And then Miravon also has pyroclostrobin, which is a FRAC 11, and this also has 100% resistance. Then we did a study looking at the increase in resistance over time to Miravon or Circadus. That's the FRAC group 7 active ingredient in these products. So in 2014, we see that none of our isolates are resistant. Then by 2018 and 2019, we see that about a quarter of the population has some level of resistance, which increases to about 60% in 2021. We did see a bit of a reduction in 2022, which could have been due to the way we took the samples that year. And then we see again about 60% in 2023. So you're probably wondering which fungicides are actually good options to apply for Stemphylium, considering that I just talked about how a lot of them do have resistance or didn't have high efficacy in our trials. So as I mentioned, our IPM program doesn't recommend Quadristop or Lunar Tranquility due to the high levels of resistance we're seeing. So for Circadus and Miravon, we are seeing moderate levels of resistance most years. So we would recommend reducing applications of that and trying to just limit the number of applications you put on to further reduce the risk of more resistance developing. So we haven't assessed a Proviatop or Miravis Duo for resistance, but we do know that these products contain one group 7 active ingredient, which probably has some level of resistance, but it may not have as much resistance as Circadus or Maravon. So that's something to consider, but we are still seeing efficacy with Miravis Duo in our field trials. So that could be a good option. As well, we are seeing efficacy with Allegro in our field trials, and this is unlikely to develop resistance. So this is a really useful product to rotate those BRAC group 7s with. Then we're going to be starting, hopefully this year, a new program to monitor resistance and hopefully give you some updates more quickly. So we've developed a method where we can capture the spores of Stemphylium early in the growing season and then test these spores for resistance to the BRAC group 7 and 11 products. And then we can let you know in our IPM reports which products you should avoid applying that growing season due to the level of resistance. So next, I'm going to talk a little bit about disease forecasting for Stemphylium. We've done some field trials on this, and basically our goal here is to limit our fungicide applications to when there's a high risk of the disease developing, so that we can still control the pathogen, but hopefully reduce our risk of resistance. So we're looking at a few different forecasting models here. One is Tomcast, which was developed for tomato diseases in Ontario. So this is kind of a general model that works for most diseases. So this takes into account temperature and leaf wetness. So basically you look at the average temperature and then the leaf wetness for that day, and then you compute a disease severity value from 0 to 4, where 0 indicates that there's a low risk of the disease developing, and 4 indicates that there's a higher risk. And then you add these up until you reach a designated spray threshold. So we've developed a StemCast model, which is basically a variation of this Tomcast model, but with the conditions that are more favorable for Stemphylium developing. So we've tested these in the field and basically looking at the StemCast model and then spraying based on different spore thresholds, and also looking at the Tomcast model and regular scheduled fungicide applications, which we call the calendar spray. In 2023, we didn't see any reduction in disease severity with any of these treatments compared to the control. So we did use diethane alternated with Miravis Duo in this trial, which didn't seem to suppress Stemphylium, as we did 6 fungicide applications in our calendar spray and we saw no difference. But we did see that our StemCast models did reduce some of our fungicide applications. So in 2024, we reduced the, we changed the fungicides that we applied in the trial to Allegro alternated with Miravis Duo. So again, we're looking at different thresholds of spores and then also the StemCast models and Tomcast models. So we see that Tomcast and the calendar spray with Allegro and Miravis Duo did suppress Stemphylium, but unfortunately the Tomcast model did not really reduce our number of fungicide applications. And our StemCast model didn't reduce disease severity compared to the control. So obviously this model still needs a little bit of work, which leads me into the next slide. So recently, we've done some work in the greenhouse to look at the temperature and leaf wetness durations that are most favorable for Stemphylium. And what we found is that temperatures between 18 to 23 cause the most infection, and then also the longest that duration that the leaves are wet leads to the most severe disease. But we've also seen that temperatures below 13 degrees and leaf wetness durations less than 12 hours don't really lead to the development of very much Stemphylium. So we're hoping that these results can help us to improve the StemCast model, which we'll be testing again in our field trials. We've also recently looked at the susceptibility of a few onion cultivars to Stemphylium. So we don't see resistance in any of these cultivars, but we do see that there is a difference in susceptibility. So we're seeing that Highlander has the most severe disease, while Traverse and LaSalle had the least disease, and then Milestone and Trailblazer had an intermediate level of disease that wasn't better than Traverse or Lascelles, but wasn't as bad as Highlander. So overall, we're seeing that our fungicides for Stemphylium were not very effective, but some of them could provide some suppression of Stemphylium. And unfortunately, some of them were not effective at all. One positive is that we did see Allegro reduce Stemphylium, and this product is really useful for resistance management because it can be used in rotation with those FRAC group 7 fungicides. Then we've also unfortunately seen that resistance has developed quickly to the FRAC group 7 and 11 products. And we're seeing high levels of resistance to Quadris Top and Luna Tranquility, and then moderate levels of resistance to Maravon and Circadus. And our resistance monitoring is going to continue, and we're hoping to give you some updates about that early in the growing season this year. Then looking at disease forecasting, we're hoping to update our StemCast model, and hopefully this will be a little bit more accurate so we can try to reduce fungicide applications and reduce the risk of resistance developing. And we also saw that some cultivars are more susceptible to Stemphylium than others. I'd just like to thank our funding sources that made this research possible and the assistance that myself and the other grad students involved in this project received from the staff here at the station. And again, all of our research trials are summarized in our Green Book reports, which can be accessed online, or we have them here today.
Question?
Good question.
Yeah.
So most
Most of the chemicals we're using now are, we're being proactive, not reactive.
Yeah.
Okay, so with you guys coming up with a system of your Tomcast or whatever, we're waiting for the problem to be in the field before we deal with it at a small amount. Are we, with the type of chemicals we have now, aren't we better off just to start and keep going? I know it probably doesn't sound right because we're supposed to cut back on the chemicals, but you know, I find on our farm what happens is between that disease and then the other one we're fighting with, I can't think of what it is, downy mildew. Like we're with these new chemicals, we're spraying pretty much every 4 days because we got nothing that's reactive. So by waiting for an amount of spores to be in, wouldn't we be too late?
Yeah, that's a really good question. It is a little hard to say when resistance develops and what the point where the fungicides aren't effective is going to happen. So part of our forecasting system is we're trying to figure out like when it's best to apply that first fungicide application. So that is part of it. And then part of the reduction is that in some years where there's very low disease severity, we don't, like, it's not going to affect your yield at that point. So we're just trying to figure out a system where you can reduce the fungicide applications in years where there's kind of a low risk that the disease is going to cause a loss in yield or affect those sprouting inhibitors. But then we also don't want that system to reduce sprays in those years where we're seeing high disease severity, if that makes sense.
Was there any unregistered chemicals that you guys are dealing with that were working? Stuff that we might be able to get later?
We haven't found anything yet. So sometimes we do have products that aren't registered that we put in the trials, but we haven't seen anything that did reduce Stemphylium. But we're always looking at different products in our efficacy trials to try and find something that does work.
Yeah, I was wondering, I didn't catch it, 3 varieties that were susceptible to Stemphylium again.
Yeah.
I-
So yeah, all of them were susceptible, but we do see that some of them, like Highlander, was worse than Traverse or Lascelles, but they are still susceptible.
What are your thoughts of incorporating biostimulants to our fungicide programs to see if that helps with the health of the onions and reducing Stemphylium? Have you guys done any work, or are you guys planning on doing any work with biostimulants?
As far as I know, we haven't done any work with biostimulants recently. It is an interesting concept, though. We have had a trial where we looked at different micronutrients and their effect on Stemphylium. Yeah, it is something to consider for sure, but we're not sure how much of an effect it would have, considering that a lot of the conventional products don't even reduce Stemphylium.
Thank you so much, Julia. We have to get into the next presentation. Our next presenter is Dr. Brian Nault from Cornell University.
Great.
Hi, Brian.
Hi, how are you?
Good, you can start.
All right, excellent. Can you all see my screen okay? And can you hear me all right?
Yes, yes.
Awesome, excellent. Okay. Well, I guess I'll start by thanking you all for inviting me to present this presentation on advances in maggot management and onion. Sorry I can't be there in person, but my schedule's just too crazy right now. But I do appreciate you accommodating me to be able to do this via Zoom. So here we go. Just to give you an idea of what I'm going to cover in the next half hour, I'm going to give just a brief overview of management tactics for maggots in onion. I'll spend most of the time on the research we've been doing on maggot management using insecticide seed treatments. And then I'll finish up by talking about what we've done recently in managing maggots in transplanted onions. And before I launch into the management, I want to give just a little bit of background about the maggots themselves. So we have two species that are very common in our part of the world damaging onions, and they are the seed corn maggot and its close cousin, the onion maggot. Now, morphologically, they look very, very similar. Generally, the seed corn maggot is a little smaller than the onion maggot, but other than that, they're pretty much indistinguishable. But they do have very different life histories. For example, the seed corn maggot can feed on lots of different things. It can develop just fine on decaying organic matter, but it obviously will attack onions. Whereas the onion maggot feeds exclusively on onions or other allium species. Both of these two maggot species can be found very early in the season in onions that are small as, say, the 2-leaf stage, maybe even smaller. And we can also find them in bulbs at harvest on occasion, and then anywhere in between. Over the past few years, we've been asking some of our collaborators from other states to send us maggots from infested onion plants that were grown from seed to see what their main species were. And again, these are very localized areas. So even though it says California, Washington, Oregon, it's just like very specific regions. But in Northern California and Eastern Washington, the only maggots that we detected in their onions are seed corn maggot. Whereas in Oregon, New York, and Ontario, Canada, we found a majority of the maggots as onion maggots. If we look a little bit more closely at the two species and their prevalence in Bradford, Ontario last year, and these were maggots that I assume, Kevin, you collected and sent our way, from the 17th of June through the 5th of July, we see early on more seed corn maggot than onion maggot, but then we see the opposite occur there in late June and early July. This isn't surprising. Based on degree day models, you'll often see that seed corn maggot adults will emerge earlier than onion maggot adults, so they just get started earlier. But regardless, both pests will kill onions early in the season. And obviously, they'll cause stand loss when this happens. And of course, there's no way to rescue an infested plant. So the best approach for managing maggots, especially targeting these early generations, is to avoid them or prevent them from occurring and infesting the plants. So it's this period of the season from planting, and that could be direct seeding or transplanting, basically, well, really March. Up here, we had growers start already March 19th. I couldn't believe it. All the way through early June. And that's the period that you have to be most worried about maggots. So let's look at different approaches for managing both seed corn maggot and onion maggot. Let's start with plant resistance. Well, unfortunately, there are no varieties that are known to be resistant to either of the maggot species, so that's not an option. There are some cultural control tactics that have been effective, but to be honest with you, probably not really practical for at least for commercial onion production. So we do know that rotating onions at least a kilometer or more away from previous onion fields or any other alliums can reduce infestations of onion maggot. It won't have any effect on seed corn maggot, but it can reduce onion maggot. But of course, that's difficult in muck production systems because we don't have the luxury typically to rotate that far away from previous onion fields. Sanitation at the end of the year, try to get rid of cold onions that are left after harvest, which again is very, very challenging. And then row covers, to put covers to physically exclude flies from laying eggs on plants. And of course, that's not realistic on large acreages, but could be done on smaller plantings. Biological control. I haven't really spent much time in my career looking at this aspect, but I did look at entomopathogenic nematodes a few years ago. And here are the results from that study. What basically we did with these entomopathogenic or insect-killing nematodes, very different from the ones that infest onion and cause problems, right? These kill insects. So we used two different species, Heterorhabditis bacteriophora and Steinernema feltii, mixed them up in a tank, and then sprayed them at the base of onion plants 3 different times in 2019, you see here. And then at the end of the season, right before harvest, we counted the number of onions remaining in plots that received the nematodes versus those that didn't. And these all had seed treatments, by the way. So they had insecticides on them. So this supplemented insecticide applications. And we see in 2019, we had about a 30% increase in final plant stand where the nematodes were applied versus where they weren't. So we were pretty optimistic. The next year we tried it, same thing, 3 applications, but this time only a 5% increase in stand compared with the untreated. And then finally, the last year, which was a COVID year, so the experiment didn't go off as anticipated. Only 1 application, and guess what? No difference at all. The other thing that I wanted to mention is that the idea that we had of applying these nematodes is that they would remain in the soil year after year after year, and maybe even build up in the soil. And this is awesome for non-rotated onion fields, which we have a lot of in New York and perhaps a lot in Ontario. And this was viewed as maybe a long-term strategy of managing these maggots. Unfortunately, the nematodes did not survive over winter. Whether it was the cold temperatures or all the tillage that occurs, not really sure. Bottom line is, this doesn't really seem to be a real great strategy for in our system anyway. Next is behavioral control. So what does that mean? Well, I had a crazy idea a decade or so ago of trying to lure onion maggot adults, the flies, to something that would kill them. And I did a bunch of research to find out what shape they were most attracted to and the color. And I found that these spheres that kind of look like a big onion, a big white onion, that was about the size of a softball, maybe a little bit smaller, were highly attractive to the flies. And then on the top of this sphere, I had a bait that was impregnated with spinosad, which is the active ingredient in Lumiverd and also in Trust. And we know that it's lethal to onion maggots, but also lethal to the adults. So the adults would feed on the top of that and then they would die. So I wanted to see, well, can I reduce maggot damage? So I had these spheres, as you can see here in the picture on the bottom, hanging, and then released a fixed number of flies into a large cage. And in the cage, I had onions planted. And what we found is that here on the y-axis, the cumulative number of maggot damaged plants during the first generation, that there was about 50% of the onion plants were killed by maggots, where there was no control at all, no seed treatments, no spheres. But where we had the spinosad-baited spheres here in the middle, and also to the right here, and this had a different treatment added to it, but we did see a reduction from 30% to maybe almost 40% well, sorry, not reduction, but this would be the cumulative number of maggots that were killed, or of plants that were killed. So we did see a significant reduction, but not a lot, but it was some. So that it gave me some promise that who knows, maybe this would work in open fields. So I deployed these spheres in open fields, and unfortunately, we really didn't see much of a reduction in the open fields. And then we encountered a bunch of other problems. For example, deer. Deer like to go through and chew on these things. I don't know why they were attracted to them, but they seemed to be as attracted to them as the onion maggot flies were. And so it ruined a bunch of these spheres. And then also we would see honeybees and other pollinators would just get all over these spheres and feed on them. And I know that they were probably going to die. So essentially that ended my work in this particular area of behavioral control. Next, we have sterile insect technique. And this is a technique that has been very, very successful in Quebec. I don't know if any of you all are using it in Ontario, but certainly the data I've seen are quite promising. This is something, though, that it just doesn't work overnight. It takes multiple releases of these sterile males, which then mate with wild-type females, and then their progeny or the babies are infertile. That's how it works. So you have to release these things for each generation, and then you have to do it over multiple years before you can see an overall suppression of the population. And another limitation of this particular technique or approach is that it doesn't kill seed corn maggots. So you'd have to also have a sterile insect technique for seed corn maggots to make this really, really highly effective. So as a consequence, we're left with insecticides and chemical control. For many years, growers relied on chlorpyrifos as an in-furrow drench. And then as it started to not work as well, as resistance started to develop, it was used in combination with seed treatments and really was the standard for decades. But as you all know, it has been banned in the United States for the last couple years or so, and it is no longer a tool available for our growers. And based on a lot of research I've done over the years, I haven't found anything else that can be applied in furrow that works really well in our muck soils. So that leaves us with seed treatments. And we have 5 that are currently registered in the United States. They're Lumiverd, Trigard, which you all call or have as governor. We have Cruiser, Suppresto, and a brand new one called Nipsit. I haven't had a chance to use it, but I will this year. And as you can see that most of these are neonicotinoids, the Cruiser, Suppresto, and Nipsit. There's a new one in the pipeline, one of Syngenta's products. Right now, the name of it is planazoline technology. Doesn't really roll off the tongue. The active ingredient is isocycloserum, which belongs to a brand new class of chemistry in the IRAC class 30. And right now, talking with folks from Syngenta, we're looking at 3, 4, 5 years from now at best for being potentially registered as a seed treatment in the US. Well, the objective of some of the research we've had over the past couple years is to compare the efficacy of these particular seed treatments alone, as well as in various combinations to control seed corn maggot and onion maggot. And luckily, a bunch of folks have been interested in conducting the same experiment. We don't have one funded project, rather each of us has our own funding source to do it. So at Cornell, we've got myself, Alan Taylor, who's seed scientist. We have 2 Cornell Cooperative Extension educators, Ethan Grunberg, Christy Hopeteen, a graduate student of mine, Leo Salgado. And then at Guelph, we have Mary Ruth McDonald and Kevin Vanderkoy, University of California, Rob Wilson, Washington State, Tim Waters, and Oregon State, Stuart Wrights. So all of us conducted the trial that I'm about to explain. But first, the treatments. So there were 14 treatments, including an untreated control that's at the top. We had 5 of the active ingredients or products by themselves, I should say. Trigard, Lumiverd, planazoline technology that isn't labeled, Cruiser, and Suppresto. And then the remaining 8 treatments were various combinations of these particular treatments. I'm not going to go through the details now, but suffice it to say, we're looking for the best treatment or combination of treatments that would best control seed corn maggot and onion maggot. So the most commonly used treatments in New York are Trigard and Cruiser and Lumivert and Cruiser. And from what I understand, Suppresto is one of your standards. So I wanted to make sure that I had these three in our experimental trial, and we did. And just for reference, they're all going to be circled in red here for the slides that I'm going to show you here in the next couple of minutes. So just as a reference. So in terms of where the trials were conducted, they were conducted in California, in Oregon, Washington, New York, Ontario in 23 and 24. In the interest of time, I'm going to only show you data from California, Oregon, New York, and Ontario in 2024. In terms of assessing the performance, we recorded the number of maggot damaged plants on a weekly basis or so through time during that first early generation. And then we took a final plant stand in July, which would cover that first generation of onion maggots. We all did that, even though some of us recorded damage even later past this, but I just want to show you something consistent up through the end of that first onion maggot generation. I'm going to show you 4 different data sets, and they're all going to be structured in the way that I'm going to show you here. So on the y-axis, we'll have the mean number of healthy plants per plot. And because each of us had different plot sizes and number of rows, there's going to be different number of plants in a plot. So don't think about or don't compare the number of plants in the different states or provinces, but just look at comparing the number of plants within the treatments at a particular location. And then we had the different seed treatments on the bottom. So here we go. First, the results from California in 2024. Remember, the taller the bar, the better the control of maggots. If we look at the far right, we see no insecticide control, had very few plants standing, which indicates that there was a very, very high pressure of seed corn maggot. And if you remember, California, in Northern California anyway, they only have seed corn maggots. They don't have onion maggots. So this trial is really good because it gives us an idea of how well the treatments performed against seed corn maggot. You see that Trigard was just as bad as the control. That's not surprising. It's no secret that Trigard is not very good against seed corn maggot. And again, that's what they have there in this Northern California location. And then if we look at the far left, what was the best treatment? Well, the best treatment, at least numerically, was Lumivert plus Suppresto. It didn't differ statistically from Lumivert by itself or Plinazolin plus Cruiser plus Suppresto, but it was the best one in terms of numerically. And then the 3 most commonly used treatments kind of in our part of the world, Lumivert plus Cruiser, Suppresto, and Trigard plus Cruiser, kind of finished in the middle of the pack. Moving on now to results from Oregon. And here, the no insecticide control did have significantly fewer plants compared with some of the better treatments, but only about a 40%, maybe a 30 to 40% reduction. So not really high pressure. And of course, they had both species of maggots at that location. Again, at least numerically, ranked number 1 is Lumivert plus Suppresto, but it didn't differ statistically than most of the other treatments, including our more commonly used ones in our part of the world, Suppresto by itself, Lumivert and Cruiser, and Trigard and Cruiser. And then what did we find in New York? This is in Oswego County, and a population that's very, very high, both onion maggots and seed corn maggots, but a majority onion maggot. And here we see that the no insecticide control had very, very few plants standing. And in this particular year, Trigard didn't look all that good. Neither did Lumivert. Now, I can kind of explain this in a way that Lumivert, this population is resistant to Lumivert. It's the first case of documenting resistance to a spinosad seed treatment, to my knowledge. But Trigard didn't work very well. And we did have more seed corn maggots earlier last year than in previous years. Maybe that's why, not sure. If we look now at the best treatments, they were Plinazolin plus Trigard and Plinazolin plus Cruiser plus Suppresto. But in terms of the best treatment that is actually registered in the United States, which is Lumivert and Sopresto, we see that as our #1 ranking, which was similar to #1 in the other locations. In terms of what is commonly used, they're up in your way. Sopresto performed equivalently well, at least statistically. And then the two more common ones for us in the US, Lumivert and Cruiser and Trigard and Cruiser, kind of finished in the middle of the pack. And then finally, results from Ontario. Here, Mary Ruth's trial and Kevin's trial, looking at mean number of healthy plants per plot, we see that the no insecticide control was lower than all of the treatments, but we didn't see a statistical separation among any of the treatments. Again, looking at this particular parameter. And of the treatments that are most commonly used in our part of the world, we see they all obviously statistically were similar, with Trigard and Cruiser ranked at least numerically as the best. And then I just showing here Lumivert plus Sopresto, which was the best one in the other locations, ranked very highly in this trial as well. So I showed you a lot of data, and I'm just trying to provide some type of guidance for providing some recommendations in the future. So I decided I would do just a very simple ranking, no statistics involved, and just looking at numerically what were the best treatments in terms of the best stands in the different locations. And I only focused on products that are commercially available in the US at this time, which of the treatments that we had in our trial are only 8. So by doing this, the lowest number would be the best treatments. And you can see at the very bottom, the Lumivert and Sopresto ranked #1 in 3 of the 4 locations. Remember, I said that we did this trial also in 2023. And although some of the locations didn't have very high pressure, we did have pretty high pressure in California and New York. So I included the data in this as well, and then took the average of all 6 of these data sets. So what I'm going to show you now were the final rankings, with 1 being the best, 8 being the worst for these different seed treatments alone and also in combination. And what we see is the Lumivert and Sopresto is 1, Sopresto 2, and Trigard plus Sopresto is #3. Interestingly enough, the 2 most commonly used packages that we have in New York and elsewhere, Trigard and Cruiser and Lumivert and Cruiser, finish kind of in the middle of the pack. So just to summarize the seed treatment aspect of this presentation, we see Sopresto and Lumivert is 1, Sopresto is 2, Sopresto and Trigard is 3. Plinasm technology appears to be promising, but not as a standalone. It's going to need a partner like Lumivert and Trigard. So in terms of recommendations for our growers, this is the approach that was taken. Some fields have very, very low maggot pressure. Others have moderate to high pressure. So I think that the seed treatment package can be tailored towards an expectation of maggot pressure. So for under low pressure, the Trigard plus Cruiser, the Lumivert plus Cruiser, and Sopresto alone would be fine in terms of the insecticide. Of course, you need the far more F300, the Evergold Prime, for the diseases. And then for moderate to high pressure, probably the Sopresto combined with Trigard or Lumivert would be best. Although one could argue Sopresto by itself also would be fine. And I can't argue that also probably would be fine, even under moderate to high pressure. So I can't leave this without talking a little bit about insecticide resistance management. There are very few new products in the pipeline, as you can see. Therefore, we have to preserve what we have as long as possible. So we need to rotate active ingredients. So why is that important? Well, let me explain. And this is really true for onion maggot because we know this pest develops resistance to insecticides. We know that it has 3 generations per year. We also know that the first generation is the most important, and that's the one that is being killed by the seed treatments, not the second and the third generations, because the seed treatment runs out of gas, right? So there's going to be no selection pressure on the second and third generations to become resistant to whatever that seed treatment is. So we can take that or consider that as an advantage when we're designing resistance management. So let me go through a real world example. In 2025, a lot of our growers are using Trigard plus Cruiser. Well, maybe in 2026, it can be switched up to Lumivert plus Suppresto, or maybe even Suppresto alone. The idea behind this is that over the 2 years, there are 6 generations of maggots, but by doing this type of rotation, only 1 out of the 6 generations will be selected to become resistant to the active ingredient that we want to preserve, which would be Trigard, Lumivert, or even Suppresto. Now, the weak link in this particular strategy is that Cruiser and Suppresto are both neonicotinoid insecticides, which that's a problem potentially in the future for other reasons, but for resistance management, it is the same class of chemistry, and we are using it here in consecutive years. So that could be an issue. All right, I only have another 5 minutes or so left, so I'm going to finish up by talking about maggot management and transplants. So in terms of what species we find in transplanted onions, overall, it's very similar to what we see in direct seeded onions, but we see a big range in differences. So for example, in Orange County in the southeastern part of the state, we tend to see more seed corn maggots infesting transplanted onions, whether they're bare roots, plugs, or sets. Definitely more seed corn maggot. In Oswego, we see, again, mostly onion maggots. In Yates County, this was in an upland, not muck soil, we see almost exclusively seed corn maggots. But overall, we do see mostly onion maggot. Now, when Lorsban was banned in the United States, growers had no products that were registered and effective for maggot control in transplanted onions. They were scrambling for basically the last couple of years. I'm happy to say that based on the research that we did last year and some in 2023, that FMC has labeled Verimark as a transplant treatment for suppression, not control, but suppression of onion maggot and seed corn maggot in onions as a transplant tray drench. So I want to show you some of the results from the research that got this labeled, okay, using a transplant tray drench. So last year, we evaluated 3 different products, Radiant, which is Spinetoram, Verimark, Cyanotraniliprole, and then the new one, Planazoline Technology. And basically, I don't want to spend a lot of time on this, but we had to basically calculate the amount of active ingredient per plant. Well, gee whiz, how do you go about that? Well, you have to know how many plants per acre, about how many plants per acre. You know what the volume is, or the amount of active ingredient, or no, formulation per acre, and then drill down and figure out how much product per plant. And then based on the tray size, the number of plants per tray, you can then figure out how much active ingredient per tray. And we figured out for our system, it was 1.24 mils per tray. Again, that can vary. It can easily be calculated. Again, if you have any questions, just give me a shout, email, phone, or whatever, and I can walk you through it. The way we applied it could be used various ways. We just used a CO2 backpack sprayer and then evenly applied the solution on a flat. We figured 1 liter of solution was enough to drench this tray without the solution going all the way through to the bottom and losing active ingredient. 1 liter worked pretty well after the tray was dried out. And unfortunately, our trials up in upstate New York were a bust because we just didn't get the pressure. But Ethan Grunberg, Cornell Cooperative Extension in Orange County, had great success. And pressure here in the no insecticide control, he had about 33% of the plants killed by maggots, whereas in all the treatments he had lower levels of infestation. Of course, what you'd love to see, especially in transplanted onions, which are expensive, right, would be 0. We didn't see that. So that's why Verimark is labeled as suppressive and not as a control product. So just to summarize this, all 3 products applied as drenches provided some level of protection. And as I just mentioned, Verimark is now registered with a Section 2 EE. Future research, we want to look at this NIPSIT seed treatment alone and in combination with the other seed treatments. That's going to be done in Ontario as well as New York and other locations. And then we want to continue our work looking at products for protecting transplants. I'd like to thank my lab for helping collect all the data, or a lot of the data that I showed from New York. A great shout out to Leo Salgado, who is a 4th-year PhD student in my program and was responsible for a lot of the analyses that I showed you today and collection of the data. A number of cooperators, and also funding sources. So with that, I hope I have at least a 5 minutes or so to answer any questions.
Thank you, Brian. Very interesting talk. Any questions for him?
No questions at all? Wow.
The products that they're using for transplants are still at 10%.
I heard something about transplant and I heard 10%, but that's all I heard. Could I?
Yeah,
hear
okay, I got a mic now.
There
So
we go.
they're saying 10% for the best. That's still very high.
Yes, yes. And you're talking about the transplants, right?
Yeah.
Yeah, exactly. No, I agree with you. That's still much higher than you would like. And in this particular scenario, 30% of your transplants being killed by maggots is a pretty high infestation. And my guess is that you're not going to see that in most locations. But nonetheless, yeah, I mean, you're right. It's 10% is still probably what, 7% more than you would tolerate. Yeah, we're going to continue to look at this, and I don't know if we have much flexibility to go higher than 13.5 fluid ounces per acre. But we can certainly talk with FMC and see if they would be willing to go higher. I think the main problem is that we need that active ingredient for thrips control later in the season. So we can't go over the maximum allowable per crop. So that's why we selected the low rate of 13.5%. But, hey, if you're not going to use Exerol for thrips control, you probably could go higher than 13.5, or at least it's something that we could explore.
We have one more question.
Hi, Brian, it's Kevin.
Kevin.
What about a seed treatment on the transplants and then the drench? You didn't try that. You said they weren't treated with insecticide, correct?
That's correct. Yeah. So, I mean, in my opinion, that I think it would be a waste. And then here's why. If you're planting seeds in a greenhouse, right, that have an insecticide on it, you may kill fungus gnats, right? But you're not going to have seed core maggot or onion maggot in a greenhouse, right? So, and given how much those flats are going to be watered, my guess is the active ingredient is going to get really diluted really quickly. So that in a lot of these seed treatments, well, I guess Verimark is somewhat systemic, but my feeling is by the time that you transplant those plants into the field, there's going to be very little protection left. So that's why I think the beauty of a transplant drench would be much better, because you do that within 72 hours of transplanting. So that all that active ingredient is going to be in that root ball, and should protect that plant from maggots. That's just my opinion.
Okay, I got one more question. Can you drench Suppresto? Is it possible?
Of course, you could. I don't know if you can get a liquid formulation of it. I have to admit that I haven't tried. Maybe you all can up your way. But that is an option. I have never tried it that way, as a transplant trade drench, but I would, if I had to put money on it, I'd say that probably would work.
Thank you so much, Brian. We have to let you go, but hopefully we see you again next year.
Sounds good. Thanks again for the invitation, and hope you all have a good rest of your day.
Goodbye.
Yep. Bye-bye.
Our next presenter is Patricia Kloepfer from Syngenta.
Good morning, everyone. My name is Patricia Kloepfer. I am a customer marketing lead for Syngenta Canada. I am standing in today for Eric Phillips. His picture is the top right of the screen there. Many of you would know him. He sends his regrets that he couldn't be here today, but his information's there in case you have any questions. Please talk to him. I'm just standing in. With that, Eric asked me to talk about 3 things with you today. The first is a new formulation of Arondis Gold. So we'll go over that quite quickly for downy mildew. Then we'll talk about Megafol, our biostimulant product, the role that it can play in stress mitigation. We have some cool trial results to share from last year. And then lastly, Allegro. It's had a few shout outs today from Julia. So we'll talk about how to use that in a program, how we would like to see it protect some of our other Stemphylium products. Arondis Gold in 2025, you'll start to see a new formulation called Arondis Gold DC. The DC stands for disease control. We're not changing anything too crazy on you here. We did change the pack size. The formulation change is actually to support other crops, not vegetables. So the only thing that you need to know is that it's the exact same stuff that you've been receiving in the jug before. It still works really well on downy mildew. And it's just a little bit of a smaller jug. So if you happen to get two different jug sizes, don't worry, it's the same stuff. For those of you who haven't used Arondis Gold yet in your onions, we're really excited about this formulation of Arondis and the power it can bring to onion growers. Part of the reason for that is just how well it works. This is a neat trial on the little green bar close to the axis there is how much downy mildew was there in the trial. It looks like a tiny little bar, but I think if you had 17 or 18% of your plants with downy mildew, you wouldn't be too happy. And then using Arondis Gold, we could see that it controlled 97% of the downy mildew that was there. So it's a great product. This rating was taken 2 weeks after the application. So it does stick around and do a good job for you there. You'll remember Eric probably last year talking about this product and that it has 2 active ingredients in it. The first is Ridamil. That's where the gold part comes. And you can see in this chart here, if you were using plain Ridamil Gold MZ, you get the exact same amount of Ridamil active ingredient in an application of Arondis Gold. The other product that you'd be familiar with from the past is Arondis Ultra. So you can see when you use Arondis Gold, you actually get a lot more Arondis with this formulation, and that's part of what gives it staying power against downy mildew. So Arondis Gold also does not need a surfactant, which I know many of you would be happy to hear. And that's part of the reason why we've seen a lot of people switch over to using Arondis Gold for downy mildew. The next product is called Megafol. Everyone's sitting here staring at me. How many of you have heard of Megafol before? A few people. How many of you have used Megafol before? Okay, there are a few people. Thank you for your pity. So Megafol is a new product that we started to offer 2 years ago. We're just recently starting to do some work with it in vegetables, and I'm really excited to share some of the onion work with you. As with most biostimulant products, they show up as a foliar fertilizer, but they also have other ingredients in them, vitamins, proteins, amino acids. Those are all taken from seaweed extract. So we've gone and harvested seaweed, extracted that, and then put them in with this foliar fertilizer. What do those things do? They help the plant do what it's already doing at a better level, a higher level than what the plant's already doing it. So that means something like frost tolerance. We can see more than 10 times better frost tolerance. Something like when there's a wound, whether that's from herbicide or whether that's from hail, you can see 65% better recovery after a wound with Megafol. So the plant's already doing these things. We're just helping it do it better with the extracts that are found in this. So this is an example last year. Syngenta did not do the ratings or pick the plants for this. This was done by someone else, a third party. So last spring, you'll remember looking at these dates, onions were probably in the ground this time last year. But the plan was to use Megafol preventatively, early season with the herbicides, any cold temperatures that would happen. So Megafol was put on at 0.5 liter an acre. And then all of a sudden there was this big frost event coming. So, okay, we're going to go back in 9 days later and try to boost the plant again to deal with that frost. So we put on 1 liter an acre. After the frost event went by, we went back about 9 days after that again and gave it a little boost of 0.5 liter an acre. And then waited out the rest of the season. No more Megafol was applied. Grower did their normal business. The only difference between the 2 sets of onions you see there is the Megafol being added early in the season. So you can see even at the very end of season, we're seeing more green leaf tissue. We're seeing bigger bulbs. We're quite happy with what the Megafol was doing there in those red onions. And part of that, yes, was probably from the plant dealing with that stress and getting over that stress better. And I do wonder if some of that was also, there's herbicide timings going on there too, right? So was the plant able to better recover from that as well? When we first had Megafol, I was in sales at the time, and we saw very similar results in other crops like ginseng and some lettuce, both from an early season application showing results all the way through to the end of the season. If you're going to try something different this year, selfishly, Megafol would be a great thing to add or to try, split a field or have one field next to another, just to see what it can do. We never know what the season's going to bring. The last little bit that Eric asked me to talk about was using Allegro as part of your crop protection program. I'm not going to go over this in too much detail because you've heard quite a bit about Allegro over the last day and a half. But we'll start with carrots, even though it's onion day. Typically, we've seen Allegro used in carrots towards the end of the season, mostly for that white mold help there once the canopy gets quite thick. Just remember that Allegro works best if you can get it into where it needs to work, right? So you don't want to wait till your full canopy is there and there's no way that you're reaching underneath. Allegro is pretty cool in that it works as an antisporulent. So once the spores happen and are starting to be released, Allegro actually kills them from spreading any further. So that's part of the reason why we want to be there ahead of time, stop those spores from infecting anything and keep anything that's there from developing further. Stemphylium. Syngenta is very fortunate. We have a great pipeline and a number of things here that have efficacy on Stemphylium. Allegro is the newest addition to the squad that just happened 2 years ago. Over the last couple of years, we've learned a number of things, tips and tricks to working with Allegro and working also with the research that's being done here on how to fit that in and keep the longevity of our products around. A lot of the chemicals now are group 7 related, and we want to make sure we break those up, whether it's using Allegro or a different product that's not a group 7. Oh, I should mention on this slide. So the research farm is also doing some resistance testing. Syngenta is doing that as well. Not because we don't trust the research farm, but because we want to make sure we're looking after our chemistry, finding out if anything's starting to slide or not work before it just stops working in your field. So that's something that we're doing to try to help along the chemistry that we're bringing to market and where resistance is quite prevalent or where there's some trouble with number of tools in the toolbox. We did their last study in 2021 and 2022. We did a 2-year survey, and then we'll repeat again in a year or 2 from now, just seeing if anything's changed with how people are using the products. I'm going the wrong way. So Allegro for Stemphylium, we already saw some good results with it. Here's some of the Syngenta results. You can see there the control, so nothing applied at all. We saw Stemphylium at about 82% infection, which is really high. When using Allegro, we saw the disease suppressed quite a bit. So suppression is a true suppression, just over 50% less Stemphylium where we were using Allegro. And that's just Allegro on its own, right? Not part of a program. So this is what we did a few years ago. When Allegro was just being registered, we did some trials, comparing to what was standard a few years ago. Things have changed a lot in 3 years, so I feel a little bit bad putting the slide up. But, when we use Allegro as one of those blockers with all the group 7s, we do see the efficacy shine through compared to a standard program of just using primarily group 7 chemistry. So just wanted to reiterate that, there's data there. There's also visual symptoms when you use this product in your program as well. So what does that look like? If you're using primarily Syngenta products for your Stemphylium program, we do need some friends. So please use Manzate, use some of the other products that are on the market as well. But we'd like you to start with Allegro early. Again, that's just starting with a different mode of action. There's that little green leaf tissue that's there. There's some herbicide spots usually, or heavy rain damages leaves a bit. So we want to put something on early, typically earlier than we like to, is what we've seen working with Nova Scotia with our products as well. Moving into bulb initiation, there we start using some of our group 7s. So if you were using Syngenta products, Provia is a good choice. It's a plain group 7. And then going back to Allegro, which is that group 29, so very different group. And then Miravis Duo, so it's a group 7 mixed with a group 3. Back to Allegro, and then if you wanted to finish off the season with Quadris Top, this is more of a Stemphylium program, but Quadris Top still brings other things to the table as well, right? That late in the season, as we heard earlier, it's a bit of a Hail Mary with what you got in the field, so we might as well make sure we're looking after all the other diseases that we have there too, and doing what we can for the Stemphylium that we're seeing. With that, I will leave you with Eric's information. Feel free to take a picture of that if you'd like. It's pretty little. But is there any questions?
Okay, so our next presenter is Bridget Visser from Stock Seeds.
Hello, everyone. I'm going to be talking about vegetable seed treatments. I would say the unofficial title of this is the ABCs of seeds. We're gonna go a little bit back to the basics. So starting from the outside, working our way in, the coatings of seeds, it's aids in the seeding process, and it's going to be unique to the crop and the seeder style. So you need the right combination. So this is an example of all of the possible coatings you can use, and carrots is giving us our example. So starting from pellets, working from our biggest. So a pellet is essentially material added onto a seed to build it to a set size specification. So if you have a size 13 pellet, it's going to be 13/64 of an inch in diameter. And the old style pellets were more of a split coat. So the pellet actually had to crack in order to release the seed. That used up a lot of water. And in some cases, you didn't have enough water to actually germinate the seed after. The new material that they're using is more of a melt, like it more melts away from the seed. So obviously we're very familiar with these here. We use them for carrots and onions and belt seeders. And then you'll also see it in going into trays for transplants. So we see it also in the leafy greens, the broccoli. You'll see some peppers and tomatoes also that are pelleted. So going down a little bit to a smaller size, encrusted seed. It maintains the raw size, shape of the seed while smoothing out all the crevices and ridges so that you can make a better connection with the holes in a vacuum seeder. You do still bring it to a certain final seed size, like on a seed count per pound. But it is impacted a little bit by the raw size of the seed. Now on a pellet, if you look down in the bottom of your pail, you might see a little bit of dust that's come off of those pellets. Dust plus a vacuum system, probably not a good combination. So I like to call it, they're finished with kind of a candy coating to limit that amount of dust that's coming off. And basically onions, parsnips, and carrots are what we see this used on the most. So film coating, that's actually broad range. It is the most common method of coating a seed. It is a slurry coat or a paint layer that consists of the pesticides, and it's just painted directly onto the seed in a way that is not going to release any powder or dust off of it. And we see it used very broadly. So speaking of pesticides, this can get a little bit tricky, not in a bad way, but a lot of vegetable seed companies are also owned under the same umbrella as a chemical division. So Syngenta makes it easy on us. Their seed division is Syngenta, Bayer, Seminis, BASF, Nunums. So if they have access to a chemical division, they're probably going to use the products that they already have the patents for, they already have the rights to, they already have the product. So you will see, if you look at certain crops, you'll see a different seed treatment blend on certain varieties versus ones that are owned by other companies. The important thing to take away from this is the seed companies know what your challenges you're going to be facing with these seeds. So they know what they have to cover the seed with. So even though you might see different products back and forth, the end goal is going to be the same. You're still going to get the coverage for the diseases that you're going to be up against. And then the other side of it is you will see labels that have the trade names, and sometimes you'll see it with the active ingredients. So I know you guys aren't shy about giving us a call if you're curious about, you know, did I get what I'm supposed to get? Totally okay, but we can answer those questions. So to just put this in kind of a real world, I know we do mostly carrot encrusted and pelleted, but I figured I'd bring it back to carrots here. So you see Seminis and Harris Moran's got Farmore 300 on it. The Ville-Moran's got a different blend. Nunum's got an even different blend. So Syngenta is kind of neutral ground when it comes to carrots. They don't have a carrot program. So Farmore 300 is available for anyone to use. But on Nunum's, you know, they've got it all in-house. So let's use the in-house stuff that we have. Now, it can change from year to year. We see this more in other crops where, you know, they'll do a couple of years with one blend and then they'll do a couple of years with a different blend. And it's all depending on availability to the seed companies. But again, what you need is covered. So there are a couple different ways you can put a seed treatment on a seed. theoretically, if the registration is there, you could broadcast a seed treatment. It's not an efficient way to do it, but you could. Seed treatment is obviously what we're talking about. It's applied directly to the seed, but it has to be done by a certified applicator, and it will come into you finished. But you also have the in-furrow method. We're familiar with that, talking about Lorsban, diphane. We know how to do this. But this is where, again, the seed companies are treating for the broad use of the seed. So if there is something specific that you are dealing with and there's a registration for a product, you have the ability to add on top of it as an in-furrow treatment, not as an actual seed treatment. So we're moving from on the seed to the seed itself now. So priming, we use it a couple different ways: quicker germination under challenging conditions, either disease or temperature, targeting the early market, and then crops with long germination periods, not to name any names, parsnips. Old school priming methods were more chemical and mechanical, and they would bring that seed past the point of no return. So you had to use a prime seed in the year that it was primed. Otherwise, if you kept it over the winter, you're going to see your germ rate just fall off a cliff. The new way of doing things is more temperature and water based. So you can bring your seed to a point where it's primed and you use it this year with the priming, but you can carry it over until the next year. But what's going to happen is it's going to revert back to its unprimed state. So you're not going to lose your seed, but you're going to lose the prime. Now, if you go out and seed it out, you will see, you probably will be able to line it early. You'll see the green, you'll start thinking about post-emergence herbicides. Don't, because if you actually go into the field and look, you're going to see, we might be looking at 20%, something like that, of plants that have popped, but the rest of them are still under there, and they're going to come up in their non-primed timing. So you're not going to lose the seed, but you lose prime. Moving back off of the plant or seed, biologicals, you're hearing more and more about this because it's another tool in our toolbox, right? We're talking about fungi, bacteria, plant and algae extracts, commonly a symbiotic relationship. So you're looking at something where the plant and the biological are both benefiting from this relationship, which is the ideal way that we have this happen. The important thing about biologicals is if you're looking at something like onion maggots, Suppresto, if you pull out a plant, you don't see maggot, you know it's working. Biologicals are a little bit more ethereal, it depends on the year, it depends on the conditions, whether or not you're going to see an impact every single year. So the best thing you can do with biologicals, do your on-farm trials, think about it yourself, basically prove to yourself whether or not you think it's worth it. So just the ones that we're seeing the most used on the seed, mycorrhizae. So we use this a lot in field environments where we're dealing with something that's just, we want to throw everything, including the kitchen sink at, white rot, for example. And then transplants, we use it quite a bit on onions to encourage your root establishment or your transplant shock period. So basically the way it works is you can do everything right, hardening off your onion plants, and they're still going to go in the field and just, sit there. Roots are basically the introvert of the relationship. You put them in a new environment, they're like, I'm not leaving, I'm staying here. It's nice and warm. Mycorrhizae is the extrovert. They blast out of that plug and explore their environment and then come back and drag the roots out with them. So you can kind of see in the picture, you're just expanding your draw. You're expanding what you're pulling from. And the benefit about this is you can apply it on the seed, you can apply it on the plug, or you can apply it across the field in furrow. I am not the person to talk to about in furrow. That's where you go talk to your pesticide people. Now, other one, bacillus. We've been playing around with this for a while, and I'm seeing now that you can get the product as more of a sprayer applied as well. So it's a bacteria that colonizes the root systems. So, humans, we drop skin cells, we drop hair as we're going about our life. Plants are much the same. As a root is growing, it's sloughing off exudates as it's growing. So Bacillus is a bacteria that basically feeds off of those exudates and then release their own. So it's creating an area of protection around the plant or the root, that it's going from being a carrot zone to being a bacillus zone. And that's how you get some of this protection from fungal diseases. Now, the pair of pictures over there, I kid you not, it was either side of the sprayer path and it was 2 full pulls. I had the luck of the Irish that day. The grower basically went from, a 0 harvest at that point to something. So everything else was the same: variety, field, spray, everything. So in that case, it's made a really big difference. In this case, you can see that there's some marketable ones, but there's still some calls in the mix. This was from a section that was treated with bacillus. So again, it's not a silver bullet. It's not the solution. It needs to be used in conjunction with other products. And one other note on biologicals: you're not going to see a negative impact if you carry it. It is a living organism. It is going to die off on you after a certain point, but it's not going to negatively impact the seed by sitting on it over the winter. Now, I'm going to take the last of my time and do a hard left turn from the title of my presentation, because I have you all trapped here. I don't know if you've noticed, but seed's getting more expensive, and it's not going to get any cheaper. So we should really talk about how we cope with this going forward. So I've got a way to do it in 2 easy steps. So first of all, you've got a field. It's 10 acres, right? Sure, it's 10 acres until you start looking at the fact that there's a road on one side. You've got the gravel, you've got all the stuff coming off of there. There's not enough depth in your soil to actually seed it. So that section's off your 10 acres. You got the river at the other end, right? Your property line is straight. Your river isn't. You've got a section that's cut off the field there. And because you are a good steward of your land, you stabilized your berm and you said, while I'm at it, I might as well square it off because it makes it easier to farm. So now we've got a 10-acre piece of land. No. By the time we actually go and do the GPS, which you guys are capable of doing now, your 10-acre piece is 9.5 acres, which on one field might not sound like a lot, but half an acre on 10 acres versus 100 acres versus 200 acres. It's a death by 1,000 cut situation, and it's going to impact your buying. Okay, so the next part, I say this with all the love in my heart. Some of you are bad at this, and some of you are really bad at this, at knowing how many seeds per acre you're actually laying down on the property. So you know what? Let's do the math. We might as well. So first thing you want to do is you want to look at the row length per acre you're actually seeding, right? So you take your row spacing, you convert it into feet, you divide it out of 43,560 feet per acre. When you're doing, the first example is kind of a carrot example, second example, onion example. Remember, when we're talking about our beds, there's 4 to 5 rows per bed. You got to take that off as well. Okay, so now we've got our row length per acre. Next step, really simple, multiply it by the amount of seeds per acre, seeds per foot you're putting down. Now, you may be tempted at this point to round that 435,988 seeds to something with more zeros. Resist the urge, right? I'll explain that in the next step, why it's important to actually keep that number whole, okay? If you want to get fancy, you can look at the amount of seed you're not laying down under your sprayer path, right? You've got 2 sprayer paths in the field, so you got 4 tire marks, right? You multiply it by the length of the field, you multiply it by the seeds per foot. We've got a simple number here. Okay, that's how much seed I'm not dropping in my sprayer paths, okay? So now let's combine these 2 things together. we've got, so if we're estimating it, right? So the first example, let's say your estimate is I need 450,000 seeds per acre. We're not actually using the on a 10-acre piece, right? So 4.5 million for the field. If we take the actual number and the measured acreage, and then we subtract off our sprayer path, now the number is 3.9 and change. Suddenly, you've reduced the amount of seed you need by 500,000 seeds. And this is, again, one field. So let's look at the onion example. In this case, we're underestimating it. We say, I think we need 250,000 per acre. Now we're looking at 2.5. But again, if we go over to the actual, take off the sprayer path, we're still overbuying by 100,000 seeds. Again, it's 10-acre field. You multiply this by your entire farm. Now I realize we want to have seed for carryover. We want to have seed for blowouts, all of our comfort level buffer seed, which is also still important, but you should be the ones driving that decision of how much seed you have as extra, not bad math doing it for you, right? So we can do our rounding at this point for the first field. Yeah, we'll take 4 million seeds instead of 4.5, but now we know we're looking at, 82,000 seeds, say, that we're over, and you can work that into your buffer number. The last thing I want to talk about is we're going to go back to seed treatments again. I tried to make a chart with all the possible combinations of seed treatments that you can do on an onion, and I failed. I'm missing ones on here. The font was getting too small and I gave up and I stopped adding boxes. So the last count, I think I had about 35 and it was just too much. So this is why you have a seed rep, right? We take care of this madness. We make sure that you're getting what you're ordering and keeping straight what everyone needs and who needs what. So all I want to say here is this is why sometimes your seed rep is very tired. So, but that's what we do for you. And we have no problem doing it. And that brings me to the end. So I'll take any questions.
Awesome. And last presenter in the morning is Charles Lalonde.
Good morning, everyone. No, I'm not Charles, but you all know me. I'm Jody from the Holland Marsh Growers. Charles is presenting on our behalf today, but I'm going to hijack 5 minutes of his time because we've got some different things we need to discuss with everybody in the room. I'm just going to give you a quick update what the Growers Association's been working on for the past couple days, couple weeks, couple months. If you have questions, please put your hands up. I know Doug will have all sorts for me. On the top of everybody's mind, yesterday I was able to be with you guys because I am now in the vaccine business again. With the outbreak of measles down in Leamington in a farm, we are now trying to get the workers and anybody else who hasn't had a measles vaccine or doesn't have it in their system that would like one to have one. The outbreak was pretty bad and everybody has a right to them. My understanding is I've worked through this yesterday in their countries of our workers that are coming. A lot of them did not have access to this years ago and it's not part of their regiment that they do. And they can decline them. So there is a lot of workers asking for them. You will get information in your newsletters. And if you need something, please reach out to me right away and we will figure it out. Hopefully by Monday, we will have a plan in place for the measles. We've also been working on all sorts of stuff. There was a gang of us that went down to Quebec City a couple weeks ago. We were very fortunate to have Matt Shepard with us. He's actually the new chair of OFEGA's crop protection, which is great for you guys. I'm working on red tape. He's working on crop protection. We should be a great team going through the province and country that way. There's a group of us heading on Monday to CPMA, which is in Montreal, and we'll be part of CDRM, which is the Canadian Marketing Produce Association, AGM, and dealing with some of the stuffs like the wonderful worlds of tariffs. And that was part of my work yesterday as well. So far, the tariffs have not affected. We'll see. So he says, who knows if he's going to change his mind. We'll see what that looks like moving forward. Right now, it's car parts and steel and aluminum. Other than that, we're all bracing ourselves to see what that looks like. But there is a committee that is working that we are part of. Anybody who was here yesterday was part of the OFVGA talks. We do work with them on a daily basis. Some days I think I talk to Gordon more than I talk to my own spouse when we're going back and forth on things. So we've been working through that way. The bigger exciting news is, and the reason why I'm also going to stop there, and you guys can read my emails and my newsletters of our updates and stuff. We're really excited for this next piece. We are working with both Bradford and King on something you guys requested years ago. We're trying to update and amalgamate the bylaws for both townships so that wherever either side has the same rules, has the same processes and what it looks like. So that started a couple months ago. We've been working with Councillor Verkuyk, Councillor Eek, Councillor Scott, and a team of, we've got a couple of volunteers, farmers representing as well. And so we're going to start that process. So I'm going to introduce you to, where's Jen and Kristen? They're going to take the stand for a minute and then Charlie will give you the talk, but it's really exciting and we need everybody to participate. And if you have questions, be kind to them. They're town employees and they're here to help us out.
Good morning, everyone. I'm Jennifer Best. I'm the Director of Growth Services for Bradford West Gwillimbury. And with me is Kristen Harrison. She's the Manager of Policy at King Township. So we're just here to do a bit of an elevator pitch to you. So as Jody mentioned, this project started a while ago and wanting to get going. So Kristen and I have taken the reins on this, and it's really to look at how can we look at harmonizing our zoning bylaws. So no matter what side of the Schomburg River you're living on, farming on, whatnot, we can assimilate and make the bylaws much better. So what we're going to be doing is there's going to be a survey coming out from Jody, as well as Matt from the Bradford Co-op, asking you about this. So our little ad hoc group, I call it, we've got a draft issues list looking at things like definitions, migrant farmer worker housing, getting that settled, on-farm diversified, that seems to be an interest, agricultural uses, anything with greenhouses, accessory dwelling units. I know there's some interest in that. Bradford has a unique area, the Morris Road area, going to be undertaking that piece as well of getting ensuring access to the agricultural properties, which seems to be an issue. So our focus is really on the zoning, but it kind of falls into a few other spots too. When you look at zoning, besides performance standards, permitted uses, and how best can we support you if you're getting an agricultural storage building, wanting to expand your business, that sort of thing. So steps on the survey is we're going to be asking questions based upon a draft issues list that we created, asking you to rank them as on importance, as well as if there's any other issues you've encountered, general questions. And then we're going to be taking all of this information, putting it together, and we've got a draft work plan, and we're going to hit the ground running on starting to knock these initiatives off over the next year or two. Anything else, Kristen?
No.
Okay, so anyway, stay tuned for the upcoming survey. Thank you so much for your time.
Good morning, and thank you for the invitation to be on the project today to talk about the 4R based program. We did several things to examine the pieces of the 4Rs. It's simple. And it's a matter of working through step by step. So the 4R program is essentially to improve nutrient use efficiency for phosphorus and nitrogen uses through 4 specific action areas, and hence the 4Rs. It's using the right fertilizer source at the right rate, at the right place relative to the seed in the ground, and at the right time. So by using these practices in sync, you end up with more efficient uses of your fertilizers. So it's going to cost you a bit less. But the better thing from it is you're likely going to have yield boosts. So we looked at a number of things. we started looking at data recording, because if you have a program, you need data to measure what it's all about. So we looked at essential features to support farm management decisions. And we looked at commercial products. We examined 7 of them. We had one company in Kingston that was prepared to design a program specifically for the Holland Marsh. But most important, the fertilizer sector has its own data management program that you as growers are all familiar with. So with a specific database that's web-based, growers have access to the data, and the information captured from soil tests to crop recommendations. So you have on that database fertilizer types, for rates that were recommended, the application time, and the application method used by the ag retailer. What it doesn't have is the actions of the grower on his own land that also can deal with fertilizer applications. And Fertilizer Canada is coming out with a report in May looking at the data management systems that are used for 4Rs across Canada. In Western Canada, especially Saskatchewan and Alberta, they've had incentive programs associated with the use of 4R programs, and their data management systems are a bit different. We conducted grower interviews, and it was not a survey, so it's not about how many people do this or how many people do that. We wanted to tease out some of the best practices that were being used. So we interviews 7 growers. We talked to 3 ag retailers and to 4 CCAs to verify the practices that are being used throughout the marsh. And when you combine that with what's in the literature, you get a basket of practices that is quite wide. But for our program, you have to focus exclusively on what affects the 4Rs as opposed to what's totally beneficial to the environment. So what we did is we looked at these practices and we put them into 3 pigeonholes. Practices at the edge of a field, like buffers, which, by the way, we're doing a project on buffers right now. We looked at reduced fertilizer use on headlands, along ditches and waterways as a means of keeping the phosphorus in the field. And we also had practices on controlled drainage. In-field practices were things like soil testing, attention to other nutrients and micronutrients, managing soil pH and calcium saturation levels, as these impact the efficiency of your fertilizer use. All of these practices are beneficial, and they help mitigate the loss of phosphorus and nitrogen to the environment, but they're not the practices specifically for the 4Rs. The 4Rs are the right fertilizer source. So we found that there's excellent use of high nutrient use efficiency fertilizers. So things that stay in the soil and become available to the plant, as opposed to fertilizers that have easy propensity to leach or to be lost through volatilization. In the muck soils, we found that there's a high use of nitrate-based fertilizers to prevent volatilization. The urea-based fertilizers break down quickly. At the right rate, that was quite a challenge. We had a research group that looked at the question, and yesterday Mary Ruth did report on one aspect of how different labs were measuring the nutrients in the soil. So what we found was that there's a need for more research in this area. And obviously, if you're going to do more research, where do you find muck soil that doesn't have legacy issues? It's going to be difficult to find here in the marsh, but we probably need a long-term study to start with a soil that is high in phosphorus. And how do you bring it down over time without affecting crop yields? That's work that would be really beneficial to the growers. And of course, we did find some growers that did a good job on rate reduction already. In terms of placement, we have an issue there. Everybody broadcasts and incorporates. It's a very quick method to deal with fertilizer in a limited amount of time to proceed to planting. And we basically have to work around that. But it's still a very basic practice that's at play within the 4R concept. And it's mitigated by using better fertilizer sources, better application timing, so that the nutrients are available to a plant. The 4R framework is basically a continuous improvement process. We'd like to make it official so that growers that want to use the concept for marketing can do so. But each grower advances at its own pace, and it starts by defining goals. If you define what you want to achieve, you can then measure whether you're achieving it, as opposed to thinking that I have a goal and trying to look back 2-3 years into your production records to see if you're making any progress. If it's down on paper, you can then have certainty that you're moving forward. And if you achieve an aspect of the 4 Rs that's beneficial, you can then move on to other objectives. And with an official 4R program, it can be certified so that when it's used for marketing, it has a solid base behind the program. So what we are doing is we produced a report. We shared it with Fertilizer Canada, and they will look at how we can integrate a 4R program for vegetable production based on our practices in the marsh. We hope to have further grower meetings as that process with Fertilizer Canada continues over time. And our report is probably 40-some pages, is on the Holland Marsh Growers website. It's worth reading, as you will get more information not only on each of the Rs, but all of the practices that are based in science. And so, do you have any questions? Yeah, Bradley.
Who's telling us that we have to do this?
nobody, it's a voluntary program, and it's only if you're in your marketing chain, there's an opportunity to gather, to satisfy what the food chain is looking for. So it could be a retailer that you're dealing with, or it could be a food processor that wants to move towards certification. In the grain area, there's been premiums for our certified production. And if you don't have a program, you can't go after premiums. So it's a catch-22. And I'd just like to take one moment. Well, the 4R program is obviously set in stone. You're going to have the same rules whether you're producing corn, potatoes, or vegetables. So that's not negotiable on how the program is structured. But within the 4Rs, there's going to be mitigating practices. And as I mentioned earlier, buffer strips is a great way to separate your production and your nutrients in the field from the water courses.
Will there be incentives to buy equipment? Because some people have old equipment, they can't.
The question is, if you have old equipment, will there be incentives? There is nothing in the works right now. The initial phase of this was to see what a program could look like for horticulture. Yeah, because I agree, if equipment is a big barrier to some practices that could be improved.
Hey, Charlie.
Yeah.
If you want us to be more accurate in spreading our fertilizer, then maybe the fertilizer companies should start coming out with like an airflow type fertilizer spreader that guys can pull with their tractors. And then we could put it down a little more accurately, because the fertilizer spreaders that they provide us are all broadcast. So how do you keep it out of your ditches and off the headlands when it's just spewing everywhere? Maybe they should provide us with some sort of an airflow type fertilizer spreader that we can use.
Yeah, but there were some growers that we interviewed that applied their own fertilizer with airflow. But it was out of all of the interviews, it was only 3 or 4. Obviously, the big irrigators have that capacity, but the pull carts that you receive to spread your fertilizer are not equipped, and that would be probably high investment area, and it should be done sooner than later. Like some growers don't spread on headlands. If it's next to a water course, simply they have the ability to shut it off, and it's pre-programmed, and you have certainty that it's done.
Any more questions? Thank you so much.
Thank you.
All right, so we've made it to lunch. Again, I'd like to thank our sponsors, Alliance AgriTurf, BASF, Bayer, Corteva, FMC, Homes, Agro, FS Partners, Seedway, Stoke Seeds, Syngenta, and UAP for sponsoring both the breaks and the lunch, and make sure you thank them as well. So enjoy lunch, and we'll be back at 1:15. Thank you.
Welcome back. I hope you enjoyed your lunch. So our first presenter is Ifesinachi Ezeh, a master's student at the University of Guelph. Here you are.
Thank you, Alsani. Good afternoon, everyone. My name is Ifesinachi Ezeh. I'm a master's student in Dr. Mary Ruth McDonald's lab at the University of Guelph. Today, I would be sharing with you one of the new technologies that we've been working on for some time now, and we used it this past season. So before I go on, it's just that not many of you are back yet. I would like to know how many of you here make use of tissue testing in your production line or your production system? No. Okay, we have someone. All right. So tissue testing is a procedure where we take the leaf of a plant and analyze it to get information about the nutrients in the plant at a particular growth stage. So it kind of gives you a picture of what is in the plant at that particular moment, like a snapshot of every nutrient that the plant has. And for most of you here that are onion growers, you would know that onion is a very tricky plant when it comes to nutrient. Any imbalance in the nutrient that onion is absorbing could lead to significant yield losses or even poor storability of the onions. So as a result, nutrient management in onions, like you all know, it's a very critical practice. Some of you already apply macronutrients during the growing season, and as well as foliar manganese during the growing season in order to support the onion growth. So, however, the current nutrient management practice that we have now, which involves sending lab samples off to the lab, has its own nuances or ups and downs. So the practice for those that use tissue testing involves collecting the samples from the field, packaging these samples in a way that is acceptable by the lab, shipping them off to the lab, and then waiting for the lab to give you back your results. This whole process can take 4 to 7 days before you can get your result. And with a crop like onions, where any delay in taking decision can be very, very disastrous. As a result of this, a device which can give you immediate result in real time is very, very important. And not only that, if you're a grower or a crop advisor that samples frequently and more often, sampling a lot of, having a lot of sampling or tissue testing during the growing season may not be cost efficient for you. So this is also where the device I'm going to talk about comes into play. So here is the device, the Piquetta lens. Lens stands for Leaf Evaluated Nutrient System. It is a device that uses AI and spectrometers to collect spectral image from the leaf, and then it's able to give you the nutrients that are available in that leaf in real time. The good thing about this device is that you are able to see your results within minutes instead of having to wait 4 to 5 days before you can have your result. So it is a portable device. You can move it from place to place. That is the Piquetta device sitting right there. You can move it to your field and use it to scan your crops in the field, or you can bring it to your office and then bring your samples to the office and then scan in your office. currently the picator lens is able to give results for 14 nutrients. And although not all crop models have all the 14 nutrients trained, but most of the crops, for the onion crop that we are working on, has 12 of these nutrients already trained. So on this slide, this is how the result looks like, the result interface. It's very easy to navigate. And on the top left corner, we have the navigation pane where you go, if you want to look at a particular nutrient, you can navigate to a particular nutrient or a particular location or the date that you scan. And on the left here, we have all the nutrients for once you select your navigation parameters, you have all the nutrients displayed for that period that you're looking at. And here is a graphical representation of each of those of the nutrient for each location or spot that you scan. And these color hues help you to interpret the levels of the nutrient that you are able to scan. Blue means that it's very high and red means that it's low. So a little bit about what we did with the device this past year is that we generated data to further train the device and enhance the model efficiency for onions. And then we compared the data that we collected using the device with the lab data to see if there is a difference. And then our sampling was done from 5 fields. One of the fields is close to us here at Jane Street. And we also took samples from 5 grower fields. And our sampling method included, for each field that we were looking at, we had 5 locations in the field, or 5 spots, the 4 edges of each field, and then the middle of the field. And in each of these spots, we had 20 plants that we were looking at every given time, 10 plants from each row, or each of the 2 middle rows in the field. So the results from the field close to us here at Jane Street show that the picator lens for most of the nutrients that it reported, the picator lens was consistently higher than the lab results. However, when we looked at the OMAFRA recommended sufficiency range for onions, we found that both the lab result and the picator were either within or above this sufficiency range. So this trend continued also for micronutrients. However, for some nutrients, there was a kind of a deviation from the trend in calcium and sulfur, where the lab results came back higher than that of the picator lens. One interesting thing that we noticed also from this field is that at 70 days after planting, we noticed that the lab results had a very high value for manganese. This time, this was just a reflection of the foliar manganese that was applied at this stage. So like I mentioned earlier, the trend was the same thing from the data we collected from the grower fields. The picator was consistently higher than the lab values for most of the nutrients. The blue line is the upper limit for the alfalfa sufficiency range, and the red line is the lower limit. So as you can see, most of the values that came back from the lab or the piquetter device was either within this range or above this range. So this trend was also the same thing. So the trend that we saw from the field here next to us and most all the 5 grower fields were similar. So the same trend continued with the micronutrients from the grower fields. So in summary of what we did with this device, we noticed, or we can say that the lab result and the piquetter results are not always identical, but they are close enough to support any decision making or that you're going to take. So since both methods were reporting values not in opposite direction, but in one direction and always within the sufficiency range. So from the results that we collected, we also can say that there is need for further improvement of the onion model. This we're going to do with all the 2024 onion data that we collected, both from the field close to us here at Jane Street and all the 5 grower fields. So where are we headed with our trials? Currently, we have growth room trials that we're conducting just to diversify or increase the avenue for data that we are collecting in order to train this model. And we also hope to train carrot and celery models so that we can use this device on carrot and celery. So in conclusion, I would like to say that as you all know, no single testing method is perfect, or combining the different testing methods is very important, and the insights that we've gained from using this device shows a great potential. We hope to collaborate with a lot of you here, growers, in collecting data that will help us further train the piquetter lens. I would like to thank my advisor, Dr. Ruth McDonald, and the staff here at Muck Station, the SGS Lab, and my sponsors for all their support. Thank you for listening.
Next, we have the onion research update by Dr. Ruth McDonald.
Great, thank you, Ifesinachi. So you heard lots about Stemphylium this morning, so I'm going to talk about the other onion research that we've been doing over the past couple of years. And the first one is our onion maggot work. So you've heard about onion maggots from Brian Nault, a really good introduction. We occasionally get that 100% or near 100% yield loss that Brian showed, but fortunately we're often seeing less than that. Most growers are getting really good onion maggot control with the seed treatments that they're using. Once in a while we see in our untreated checks, we see an onion like this that's full of onion maggot, but we very rarely see any of those losses in the field except in our research plots. But we do see a variation from year to year. So 2020, we had about 40% loss in our untreated check. Some years it's really low, even when we have no insecticide, up and down. And in this past year, we did have relatively high maggot damage, which means that we actually have a good trial to test some of the products. And Brian mentioned the new plinazoline technology that we've started to look at. And we're really interested in Ontario about the new formulation of spinosad, Lumiverd. We've never been able to get spinosad registered on onions in Canada. So we're really happy that Corteva is taking this forward. And now it seems like we have a better chance of getting this registration. We have probably 15 or 20 years of data that shows that it actually works well. And Brian Nault was able to show that in his trials as well. We've been part of that project that Brian organized that's in several states in the United States. We're doing this with onion safrain, of course, seeded in our trials here at the station with Evergol Prime on the seed. Someone was asking this morning about why we don't have far more 400 or 500 in Canada, and we've just never been able to get those insecticides registered. And when we do our trials, before the onions even get up, we stake out 2-meter plots. So we assess the onions, count the onions first, and then as the maggot damage shows up, we count how many onions are damaged. And we also stake out our yield plots right at the beginning. So we don't do anything to the yield plots. We can get a good estimate of yield at the end of the season. So these are all of the same treatments that you saw with Brian Nault. In our 2023 trial, we had very low maggot damage, even in our untreated check, just under 9%. So everything reduced maggot damage. At the end of the season, a few of the best treatments had no maggot damage at all. So it was good to see the Governor, which is our standard, was very effective. And the Lumiverd plus Cruiser looked good, but they were all effective compared to the non-treated check. And then in our 2024 trial, we had that higher rate of maggot damage in the non-treated check. Again, all of the treatments resulted in far fewer onions that were damaged. And the only one that was different, Cruiser, wasn't quite as effective as some of the combinations, but combinations with Cruiser, like the Lumiverd plus Cruiser, was giving us really good results. So this data looks a little bit different from what Brian showed you this morning. We're looking here at percent maggot damage, so the percent of onions with damage. Brian was looking at it from the other way and looking at the number of healthy onions without damage. So the results are showing us the same effective treatments. We're just looking at them in two different ways. So just to wrap this up, we did have relatively high damage. From our point of view, we're happy to see that because it means it's actually a good test of the treatments. But trends were similar both years, and all of the treatments were more effective than the non-treated check, which we expect to see, but sometimes when we're working with a disease like Stemphylium, we don't always get those results. And we can identify the combinations that are working well and the one single product, Cruiser, that wasn't quite as effective on its own. So we are repeating this trial again. It's that same multi-state trial. We've been told that plinazoline won't be registered on onions for several years. So we're looking at some more of the combinations with Governor and Lumiverd, but we are keeping the plinazoline technology one treatment in our trials. So we'll always be able to go back and do a comparison with that seed treatment. So if you want to read up more about Brian's work, I refer you to this article in Onion World. It gives a really nice summary of the work he's been doing. So we've also been spending quite a bit of time looking at products to control downy mildew. And we've always had downy mildew forecasting as part of our integrated pest management program. You'll hear a summary about that program later on this afternoon. Many of you probably know that cool, wet conditions are conducive to onion downy mildew. If I'm driving up to the station and it's a foggy morning in the middle of the summer, that's really good weather for downy mildew to get started. And we use this downcast program to forecast downy mildew. For all foliar diseases, it's really, they work better if we can apply the fungicide to the leaf before infection takes place, but this is even more important with downy mildew type fungicides. It can be really difficult to see those first signs of sporulation on onions in a field. And when we do see them, we know that infection actually took place 9 days to over 2 weeks before that. So that means you really had to put the fungicide on even before you see the symptoms. And also, we don't get downy mildew developing in our fields every year. I usually say 1 year in 4, but the last 2 years we have seen downy mildew in the marsh. But because we have those years where there's no downy mildew, you don't need to put on the specific fungicides for downy mildew, that makes disease forecasting even more important. And we didn't see any in 2022, but we did have it the past 2 years. So there's been a lot of research on this disease. There's a lot of information about the temperatures, leaf wetness, what the temperatures need to be overnight, how quickly infection can occur, and quite a wide range of temperatures. So these all go into the disease forecasting program. And we've also started to incorporate, evaluating the spores in the air, because we can get those environmental conditions that are good for disease development. But if there are actually no spores around to germinate and cause infection, then that reduces the risk that disease will actually develop. So we've been looking at a number of products for onion downy mildew. The standard Ritamil's been around for a long time, and Arondis and Arondis Ultra has really been a standard for the past number of years as well, along with Zampro. So we're fortunate we have a few very effective fungicides registered for downy mildew. Picarbutyrazox is a new one that is supposed to control this type of organism. We included it in our trials. Also, 2 biological products, Serafel and the trichoderma product, T77. And Diplomat is an organic, it's a chemical, but it's an organically approved product for use. And of course, we compare these to the non-treated check. So in 2023, lots of disease. These are the number of lesions in 2 meters of row. So over 80 lesions in actually the Diplomat. So you can see it was no different from the non-treated check. The T77 wasn't particularly effective either. Serafel wasn't statistically different, but it did look like there might be something happening there. But down at this end is what we're really interested in. The Ritamil alternated with Arondis, Arondis on its own, very effective for reducing downy mildew. And this year, 2023, disease came in relatively late. And so we didn't see any reduction in yield. And we think that's because the onions were already well into bulbing before the downy mildew really got established. But it did kill a lot of leaves. So even though you have yield, there wouldn't be a lot of leaves left to uptake MH as a sprout inhibitor in that situation. So 2024, We took out picarbutyrazox. We didn't think that would be very effective, kept in Seraphyll. And we added pristine because it does say suppression of downy mildew on the label, though it's not really in the group of fungicides that should have effectiveness on downy mildew. In our main trial, we had less disease pressure, so we didn't have any statistical differences. Seraphyll didn't look particularly effective, but the trend was the same at this end with Zampro Arondis, and in this case, we alternated Arondis with Zampro. But fortunately, we had a couple of other trials on station, and for whatever reason, where they were located, we did get some significant differences. So we saw a nice reduction in downy mildew with Arondis in the one trial. And we looked at an experimental product, and it was really nice to see that that looked very effective as well. Differences in yield in this trial, no differences in that trial. That's probably more due to in-trial variation than anything else. So to summarize this, we had a good trial with high disease in 2023. We could really see how effective some of the fungicides were. Same trend in 2024. And just Arondis Ultra with Ridamil, very effective. As always, it's important to rotate the modes of action of fungicides. And it's always nice to see something new coming through the system that looks promising. So I just want to emphasize again that with downy mildew diseases, even more than other diseases, fungicide timing is really important. And that's why downcast and disease forecasting is important as well. And the IPM program seems to be doing a pretty good job with downy mildew forecasting. There were a few fields in 2024 where the scouts saw downy mildew, but all at low levels. So it looks like everybody got the fungicides on in time and kept the disease under control. So you've seen this a lot already, but we do have copies of our report. All of this is in our report and available online. And I want to we actually get funding from the California onion growers to support part of this. Of course, we appreciate the support from the Bradford Co-op and the fresh vegetable growers, and we couldn't do it without our research team. So is there time for questions?
I'm just wondering why you don't focus more on the sterile insect technique for onion maggot.
We don't have enough time for me to explain that here, but in short, it's very difficult to do it in an area as large as the Holland Marsh because all of the growers would have to do it. Otherwise, non-sterile flies will just fly in from the next field. There are some reasons that I'm not 100% convinced that it's quite as effective as some people report it to be, but that's a longer discussion. But one of the things is because the marsh is contiguous with 7,000 acres, really you'd have to get every onion grower on board.
In the Netherlands, they do it for many years, and it's very effective.
Right. So there's a discussion about whether there's actually insecticide seed treatments on the onions. I'm not sure about the Netherlands, but a lot of the onion growers in Quebec still use the seed treatment. And from our results, I'd argue that you don't need the sterile males because the seed treatments work so well. But it's going to vary from location to location.
Okay, thank you, Mary Ruth. Next, we have the Corteva industry update by Alana Respondek.
Good afternoon, everybody. How are we feeling? Doing good. I think I'm second to last. You're getting through. You're almost there. You're almost there. I did not respond in an appropriate time to the ask if I wanted to present. So I'm the last industry rep to speak, and I'm actually going to talk carrots. So I'm sorry. But, I'm going to focus on one product today, and that is Celebro nematicide. So I'm just going to review some key points with this one product, a nematode review, nematodes in Ontario, Celebro in general, how it works, application rates, and some pictures. So plant parasitic nematodes, that's what I want to focus on. And we know that the soil food web can be thrown off balance by plant parasitic nematodes. They are harmful to the soil, harmful to plant health, but they are only a small fraction of the soil nematode community. But this small fraction can inflict quite a bit of damage. Oh yeah, there we go. So why should we care? Why do we need to be concerned with nematodes? Well, the picture on the left could be anything. It could be drought, it could be nutrient deficiencies. It could be waterlogging. It can also be nematodes. So it's difficult to figure out what is going on with your crop. The other fun fact, nematodes have a very, very thick cuticle, which makes them tough to kill. They are also very, very reproductive. Their eggs you can have at least 500 little nematodes in one egg sac. And so the damage that plant parasitic nematodes can cause, if you look on the picture on the right, this is of tomatoes. We have knots or galls. We know what our root system is meant for. It's meant for stabilizing the plant. It's meant for taking up nutrients, water. And if your root system looks like that, it's not a very efficient system. Plants that have clean, nice roots, lots of white root hairs, tap roots, that's going to be efficient. That's going to promote healthy plants. Here's another example. Nematodes can cause a lot of forking, galling, unhealthy, unmarketable roots in carrots compared to what they should be and what you were aiming for with carrots and limited nematode production. So over the last 3 years, I've been taking soil samples around the province of Ontario as I myself learn about nematodes. And sorry, I'm blocked. All good. And so I just brought my soil core around, and so we were down in Chatham, Essex, Kent, London area, Norfolk County, Niagara. I do have a couple in here, but they were done prior to me. So I wasn't the one that actually took them. My predecessor, Chantel, took them. So all through the province, we're taking samples. And as you can see, nematodes are here. We have 9 different species of nematodes in Ontario, and that's plant parasitic nematodes only that I found, not the good guys. So I'm talking Celebro nematicide today, and we have reason to talk about nematodes and nematicides because they are here. So goals with nematode management plans. So if you have nematodes on your farm, our goals for a management plan, we want to protect that functional root mass. We want to make sure we're protecting the quality of the crop. We want to reduce nematode multiplication. And in general, we want to preserve our beneficial organisms in the soil. As I said before, plant parasitic nematodes are only part of the soil food web. And we have problems when that food web becomes unbalanced. So we want to be preserving all the other organisms within that soil profile. So Celebro nematicide, I come to our product now. And so what is it? It's a non-fumigant product, but it is a chemical product. It is targeting plant parasitic nematodes. It has a really good ecological profile. It's a suspension concentrate. I think there should be a trivial pursuit for chemical names used in agriculture. I think it would be a great fun board game. fluazine, dolinazine. Did I get that right? What do you think? That's what Celebro is. And it is registered in vegetables along with fruit. So how does it work? This product, highly selective, okay? It's contact, not systemic, and there is no ovicidal activity. Unique feature number one, after you use this product, what it's going to do is it's going to cause symptoms in the plant parasitic nematodes that are zigzag, J, coily shapes. And essentially, this is causing the nematode to stop being a regular nematode, stop feeding on plant roots. Too fast. There we go. Unique feature number two, great soil mobility, great residuality. So Celebro does move through the soil complex. You can see here it's going to be from a drip tape, it is moving down through the soil profile where the roots are. There is also a great testing with residuality. This particular test was 8 weeks long. Celebro was the blue line. You can see that there was still Celebro at great amounts 8 weeks into this test. So that's unique feature number two. Unique feature number three, outstanding safety profile. Green is good, right? And these are all your toxicity, ecotoxicity. Green is good. So we're rating really high on safety. And again, we are preventing death of the beneficial insects. So great on the beneficial community, wonderful for an IPM program. Again, just to sum up how it's working, you have your exposure time in days on the left here. And so at 1 day after application, reduced motility and activity of those nematodes. So something's gonna happen right away. 1 to 2 days after exposure, reduced mobility. So they're not gonna move as much. Also great, so our crop is not getting killed. And then 2 to 4 days, those nematodes have paralysis. And at 4 days, there is death of those nematodes. Really, really fast acting. We want it to be fast acting because we do know that with nematodes, the main cause of damage is early on in the crop's life. So we want to be protecting that crop right away at planting. The optimum time for application of Celebro, plus or minus 2 to 3 days. I've had growers put it on at planting. So really flexible in terms of its timing, but we want it to go on early. Crops such as carrots might benefit from 2 applications, which is on the label. And so again, from our vegetable standpoint, we are registered on a bunch of vegetables. We'll focus here on the carrots. We have a rate range and we have a couple different application methods. Pre-plant, incorporate, broadcast, incorporate. You can, if you were set up with drip, you could go post-plant with chemigation application. There is a range, as you'll see here, and I just want to put one call out. The Muck, with its unique soils and high organic matter, we do know that Celebro binds to high organic matter, something that we've discovered in our testing. And so you might be better off with the high rate in your soil conditions. A couple pictures to show you. Oh, I skipped one there. There we go. That was from the Maritimes. Untreated on the left, treated on the right, handfuls pulled out. You can see that they did get more marketable yield with the Celebro treatment. Alliston, there was some fields in Alliston that were treated in 2023. On this particular trial, there wasn't high muck, so we did go at the lower rate. Pre-plant, broadcast, and incorporate. That was us just walking the field, pulling some out. They looked beautiful. This was a really unique case because this particular field, the grower tilled it under the year before because it was so knotty. They didn't have any marketable yield. So they were quite happy with these results. I'll finish up by saying I only talked about one product in the Corteva portfolio. We have a bunch. Thank you if you're using them. If not, still, I appreciate what you guys do. Continue growing carrots for me because I enjoy eating them. If you want to ask me any questions, Celebro or not, don't hesitate to reach out to me. Have a great day.
Okay, good. Next is IPM update by Tyler Blauel.
Thank you, Ifesinachi. So today I just wanted to give an update of our IPM program and what we found last year. Pretty much a bit of an overview. So first off, the objectives of our IPM program are first to scout your grower fields. We also do disease and insect forecasting, identification and diagnosis of weeds, diseases, insects that we're finding in your fields. We also want to provide growers with timely, accurate, and convenient access to information on diseases and insects and how to best deal with them. And we're always constantly trying to improve and update our IPM program. So if you have any suggestions, if anybody does, feel free to reach out to me. I'd be happy to discuss making those updates. Throughout the season, we send out a IPM update or AgriPhone email twice a week throughout the season. In these IPM updates, we have your current weather information, current disease and insect pressures that we're currently facing, disease forecasting, when any diseases might have high pressure, things like that. Possible control recommendations or products that we'd recommend for you to control specific diseases, insects at that time, any new products that are coming about or being registered, and any upcoming events that either we're hosting or a part of, we'll be posting there as well. And before I go any further too, I just wanted to thank our funding partners, the Bradford Co-op, all of you growers who participate in our IPM program through scouting, all of our chemical company sponsors, and also the Ontario Agri-Food Innovation Alliance. It's with all of your guys' help that we're able to operate our IPM program. All right, now let's get into the weather that we experienced last year. So in terms of temperature, our May was pretty warm compared to our 10-year average. And then the rest of the year was pretty comparable to our past 10 years. But when we look over at our rainfall, this is when things were a little bit different, got a little bit interesting. We had a little bit higher rainfall in May compared to normal. And then we also had quite a bit of rain in July as well. And then the rest of this season was quite dry. So we all know we had a bit of a drier fall. The wetter start to the year, it was very good for plant health, but it was also made conditions good for diseases to develop as well. One other aspect of our IPM program is our diagnostic lab. So last year we received around 129 samples. Most of these were diseases, 63%. Fewer were insects at 8%. And this is a service that's available to everyone. So if you have an issue going on in your field, you're unsure what's going on, feel free to bring in a sample and we'll do our best to ID what's going on for you. And again, that's available to all growers, industry reps, anybody in the area who's looking to get some answers. And in terms of grower participation over the past many years now, for our scouting, we've been maintaining a pretty consistent scouting acreage here, and we're really hoping to kind of keep it that way. Okay, now to move on to carrots and what we saw in carrots last year. So the main disease that we started to notice in our harvest samples when we assessed them in December was this crater rot. So crater rot, it creates these dark lesions here, and it's caused by rhizoctonia. And it was really more so coming about after a period of storage. We weren't seeing this immediately out in the field when we were pulling carrots. It's something that developed in storage over a little bit of time. Cavity spot was fairly common, but severity was very low. Likely had to do with how dry the fall was. We also had quite a few forking and stubby carrots. This can be caused by a number of things: Pythium, nematodes, some abiotic factors, and there's some fusarium. And those were the main diseases that we were finding throughout the year. Things like leaf blight it was quite low compared to other years. And again, this is probably because of a bit of a drier fall. Also, Sclerotinia white mold, that's often something that we deal with in the fall, leading up to harvest, something that we don't want being tracked into storage. And again, because it was such a dry fall, conditions were not super conducive for Sclerotinia to develop. And just to kind of graph it out, give you a bit more of a visualization of what we were finding in our harvest samples. So we found crater rot, stubby and forking carrots, and cavity spot in all of our fields that we were scouting. However, the incidence wasn't high in a lot of cases. Crater rot, the field that had the most crater rot, we found around 45% of the carrots had crater rot, which is high. A little bit down the list here, aster yellows. We were potentially expecting aster yellows to be a little bit higher this year. We did have pretty high consistent populations of aster leafhoppers, which are the insect that's the vector for the organism causing aster yellows. But at harvest, we really didn't see a whole lot of aster yellows, which was good. And overall, max incidence was quite low. Now for carrot insects, the main insect that we were dealing with last year was carrot rust fly. This small little larva causes lesions or damage similar to this throughout the field. We were also looking at aster leafhoppers, as I just mentioned there. Interestingly, carrot weevil, something that we've really had to deal with for many years now. We're starting to see lower and lower pressure, which is great. And also a little bit of cutworm here and there. So I just have some insect graphs here. They're going to have 5 lines on them. And those lines just represent the average counts that we were finding in the different regions of the marsh here. So we just kind of divided up into north, east, central, south, and west. So to start off with carrot weevil, again, carrot weevil populations were generally quite low compared to previous years. Our highest populations were found in the central region, as you can see here. I think it was roughly 16% or so of the fields surpassed this 1.5 cumulative weevils per trap threshold. So that's when we recommend you spray once at the 2-leaf stage, and around 11% surpassed the 5 cumulative weevils per trap threshold. So a little bit of a step down, but that's much lower than previous years. And one great result that we found last year was from our harvest samples, we didn't find any weevil damage. So this is the first time in a long time, as far as I know, that we've never had weevil damage in the marsh, particularly from the carrots that we harvested. And I showed these next couple of graphs last year, but I just wanted to show them again and kind of update and include our findings from this year. So this decline in carrot weevil population and damage, it's a good success story of a couple products, one in particular, Rymon, the registration and uptake throughout the marsh. Back when it was just registered and growers started using it, we really started to see this decline in weevil population, weevils per trap that we were finding out in your fields. And this definitely correlated with the amount of damage that we were finding at the end of this season. A steep drop off. These bars here are no more than 0.25% weevil damage. And then again, in 2024, we found 0% damage, which was great. So Rymon, it is a very good product. XRL, it's another product that's registered. And if you're experiencing high populations, it's probably good to rotate the two. In terms of carrot rust fly were a bit more of an issue this past year. The population was decently high at the beginning of the season. This first generation, though, it really can't cause significant damage. It's more so this second generation that you're seeing pop up over here that can cause quite a bit of damage. And most of the highest populations were found in the central area of the marsh last year. And that correlated with what kind of damage we were seeing in the marsh, around 0.5 in the north, 1% on average in the east, 9.1 in the central region, and then we have zeros in the south and west. In terms of after leafhoppers, I was mentioning that we were finding decently high, consistent populations throughout the season. And this can be seen here, a lot of peaks approaching that 20 leafhoppers per trap threshold. But luckily, there's a good chance that a lot of those leafhoppers didn't actually hold that organism that causes aster yellows. So in summary for carrots, crater rot was very common, especially after a little bit of storage time on our carrots. Cavity spot was lower than in previous years. Leaf blight severity was low, along with Sclerotinia white mold. Carrot rust fly damage was low generally throughout the marsh, but it was just high in some areas. Aster yellows, again, we were expecting that to be higher, but it ended up being lower amount of symptoms and damage, which was good. And again, we didn't find any carrot weevil damage this year. And again, we had a dry fall. Having a dry fall, potentially there's a chance that some of these carrots may have gone in a little bit drier than we're used to. While they're in storage, it could have given the Rhizoctonia a bit of an opportunity to infect our carrots and just continue to show their symptoms and create those lesions that we saw in storage there. All right, now moving on to onions. The main onion diseases that we were finding last year, well, the main one is Stemphylium. We did find quite a bit of pink root, but pink root severity was very low. Purple blotch and a little bit of downy mildew here and there, but as Mary Ruth had mentioned too, it was really kept at bay, and some bacterial diseases with the wet conditions and the fairly warm temperatures. So just graphing it out again here, we found Stemphylium and pink root on all scouted onion fields. The max incidence for Stemphylium was 100% in a lot of fields, and severity was quite high in a lot of fields when we were getting up to harvest. Downy mildew, as Mary Ruth had mentioned, we found it in 7 grower fields this year, but it was really just small patches here and there, 1 or 2 patches in a grower field. And just this simple graph right here showing Stemphylium leaf blight. Stemphylium leaf blight really kind of started to take a hold a little bit earlier in 2024 compared to previous years. By mid-July, we were seeing a lot of fields with around 50% of the plants having Stemphylium. And this usually isn't seen until usually maybe 2 weeks after, somewhere around the end of July, early August, around 50%, and then it kind of spikes up. But with the warm conditions, with the increased precipitation, the environment was humid. There was longer periods of leaf wetness. In July, Stemphylium started to infect a little bit earlier. It was basically had the conducive conditions to do so, and just kept building from there. And in terms of onion insects, thrips and onion megaflies, those are the main ones that we're looking at. Both, though, they weren't a serious issue last year. In terms of onion thrips, we have generally a 3 thrips per leaf threshold. That wasn't hit in any scouted onion field last year, so that was good. Onion thrips populations remained fairly low and fluctuated a little bit throughout the season. And I just wanted to point out too, we have some good products for onion thrips, and the first being Movento that should be put on at the beginning of the season, back to back, as your thrips populations start to build. And then after that, that's when we're looking at applying another insecticide when you're at or surpassing that 3 thrips per leaf threshold. For onion maggot flies, populations were quite low overall. These are much lower numbers than we've seen in previous years. A couple small spikes kind of here and there, but nothing too alarming. And the seed treatments that we're using, Suppresto, it seems to be doing a very good job. So in summary for onions, Stemphylium leaf blight, it was present in all fields. Severity was pretty high in a number of fields as well. A lot of transplants though, they started lodging kind of around the end of July, and they were looking pretty good at harvest. They kind of missed that window of high Stemphylium infection. It wasn't until kind of later on in the season when things got a little bit drier. Onions may have been just, maybe slightly a little bit stressed, that we really started to see Stemphylium kind of take hold. Downy mildew, it was pretty minimal last year, but it was found. White rot, onion maggot damage, they were very low. They were kind of more diseases that we were finding in transplant onion fields. Pink root, again, it was found in all fields, but severity was very low. And as I was mentioning, the wet and warm conditions, they were good for many diseases to develop throughout the season. So I'll just quickly go through celery here. For the most part, we really didn't see a lot of celery issues last year. Blights, leaf curl, pink rot, we saw a little bit of each, but they were all managed very well, and we didn't see any major outbreaks. And same thing for celery insects as well. We saw tarnished plant bug here and there for sure. No major damage as well though. Aster leafhoppers again, decently high populations, but no significant aster yellows popping up here or there. And we didn't see any carrot weevil. Sometimes we can see carrot weevil in celery, but we didn't see any this year. So again, all the celery insects were managed well as well. So just want to mention one more time, the Green Book is available here for if you'd like to pick up a copy. The IPM report is included in our Green Book here as well as all of our other trials. And I did want to mention and point out the diseases that we're looking for while we're scouting your fields. We have our list of diseases here, the crops that they affect, and also the model that we use to predict when they may be of high pressure or not. And the same thing for our insects. These are the insects that we're generally looking for throughout the season in the crops, and their degree day models that we use to predict when they're emerging or when populations might be, when we expect populations to maybe be a little bit higher. And part of our IPM program too is to conduct our spore program. So in addition to the forecasting models that we run using our portable weather station, we also put out rotorod spore traps. And the point of a rotorod spore trap is to collect airborne spores, things like downy mildew, Stemphylium, Alternaria, and Botrytis, just to see when those pathogens are actually around, and if the forecasting model is showing that it could be potential conducive conditions for them, then that kind of warrants a critical time to go out and spray for them. So in terms of the IPM program for this coming year, the price that we're looking at for scouting per acre is $65. We are still continuing to look to scout twice per week throughout May until harvest. After August, the carrots will be scouted once per week throughout September. And as we mentioned last year too, and we started to incorporate, we now have an app that the scouts use, and they can use that to create electronic reports to send you through email. So these are just PDF reports that you can get to your email. You can get them on your phone. You read them in the tractor, at home, wherever best suits you. We can also continue doing the physical reports if those best suit you. And we will be doing, again, our IPM reports that we send out twice a week throughout the season. And if you're interested in signing up, feel free to let me know anytime before the growing season, really, up until, that first week of May. That's when I kind of like to start collecting everybody's information, and I'll be reaching out to everyone as well leading up to that time. So feel free to call the station, email myself. And if you'd like some more information, please visit our website. You can also check out our X account. I try to put out important information throughout the season there. And if you're interested too, please check out and subscribe to our YouTube channel, Muck Crops IPM. We have some interesting IPM videos loaded up there. And just to touch on our scouting report app. So this is something that the scouts use. You don't need to download a new app or anything like that on your phone. The scouts generate these PDF forms that we just send to you directly by email. And this is kind of just an idea of what you'll kind of see. So instead of, having to go to your report barn in the past, looking up the past report, looking over at the graphs that were also there, now everything's kind of included in one electronic report, and you also have some pictures included there. Basically, everything that was on your physical paper reports, it will be in your electronic reports as well. So with that, I would just really like to thank once again all the growers who participate in the program, our IPM scouts, and all of our chemical company sponsors, Bayer, FS, BASF, Corteva, Syngenta, also the Bradford Co-op, the Holland Marsh Growers Association. It's with all of your support that we're able to make this IPM program run. And it's with the support of all our chemical companies as well that we try to keep costs down as much as possible. So with that, I'd be happy to answer any questions if anybody has any. Right. Yeah. So, so the IPM program, it used to always be a part of the Department of Plant Agriculture. Under Mary Ruth's watch. Mary Ruth is always going to be keeping an eye on the IPM program, that's for sure. But we've transferred the IPM program over to the Office of Research under Shawn. So I'm with Shawn now too. So we're still going to be operating the IPM program exactly the same as we always have. But just to let you know, we're now just technically under a different department with the University of Guelph. All righty. There's no questions. Thank you. We'll get to our last presentation.
So last but not least, yeah, we have the onion cultivar updates by Shawn Janse.
Okay, well, thank you very much for holding out, and it's a lot better day today too than yesterday. So now I'm going to talk about my onion variety trials that I had in 2024 here at the Muck Station. So as far as the yellow cooking onions go, I seeded them on May 6th. I had 34 cultivars from 6 different companies. I pulled and topped them on September 18th and 19th. They were basically dry and dead in the fields. We were able just to pull them right out, take the sample and combine them right away. We did the evaluations the 25th of November through the 3rd of December. As far as some highlights of the trial go, germination and vigor were fair. Growth was steady and satisfactory through the summer, even though we were into some of the dry spells. It carried along quite nicely. Insects were kept at very manageable levels. Never had anything crazy as far as thrip population or anything like that. Stemphylium leaf blight, moderate. Of course, more of an issue late July into August. High percentage of tip dieback though this year. We noticed that in the varieties. We had a lot. I think a lot of guys out there also had that, but it was certainly a case inside the variety trial. And there was the odd cedar found in the trial this year on a few varieties. Average yields, basically when said and done, we did see slightly, kind of what I mentioned the other day about in the carrots, slightly unevenness in the reps. So statistically, we noticed a little bit of difference in yield and some evaluations in between the various reps. Stand counts were at about 7 a foot, ended up being the most common call was a peewee or an undersized onion. Good neck finishes. They were mature when they were harvested. No problem that way. We noticed too this year they were slightly lighter in color. They didn't have that dark, heavier, thicker, darker colored skins. They were more a little lighter and a little lighter in thickness and also in color. And the quality of the skin was still fair overall. Looking at some trial averages, again, 7 onions per foot was a thing. It was down a little bit from last year. Bushels per acre averaged about 1,080, a slight increase from last year. Onion maggot damage was almost non-existent, 0.8%, just gone with the Suppresto now. 102 days for harvest, which was a decrease compared to 2023. 8 for firmness, so this year they ended up being more firmer than what we saw last year. Probably because we were in more drier conditions, probably tightened them up a little bit. And score or qualities averaged at 6.85. Looking at percent marketable, the trial average was 94. It was a slight increase compared to 2023, ranged from 98 to 87. As I showed there, a bit of a bump up overall. Half the trial was higher than 94%. Again, the most common call was a peewee or undersize. And the 6 varieties that had the highest percent marketable, Parecchio from Herzera at 94.8, Lodestar from Seminova at 94.7. And this year we did something a little different. We put a hard ball in there to give you a bit of an idea for size-wise inside the trial. LaSalle from Stokes at 94.7, Highlander from Tacky at 94.6. And again, from yesterday, if you remember, a number behind there, it's been 4 years now that LaSalle has been one of the top 6 in percent marketable. So just to repeat there, just a reminder, you'll see that through some more of the trial. Safrane from Bejo at 94.5, and Overlook from Stokes at basically 94.5 also. So those were the top percent marketable onions out of the trial. Looking at yield, again, trial average was 1,080. It's actually up by 120 compared to last year's 2023's. Which I was a bit shocked when I was doing it. I thought the average was, or sorry, the yield this year was okay. And I thought it might have been down, but when I look back, we had some pretty poor yielding ones in 2023. So that kind of was a bit of a skew there. It ranged from 1387 to 793. Again, we're sampling a very small area. An extra onion or two soon adds up several bushel baskets. So you have to use that as a comparison. Approximately half the trial was above 1,100 bushels. The majority of the onions in the number wise, when we're counting them out, fell in the 2.5 to 3 inch size range ballpark. The 6 varieties that had the highest amount bushels per acre yield wise, Catskill from Stokes at 1387, Killington from Seminus at 1285. Again, Catskill is the 3rd year that it's been in the top 6 or so for bushels per acre in the trials. Ridgeline from Tacky at 1274, a number variety from Herzera at 1273. Yakima from Bejo at 1241 and Valencia from Bejo at 1234. And it's the 2nd year again for this one to be in the top yielding. Jumbos, so looking at anything that's 3 inches or greater in size. Again, trial average was 13.3, was up by about 10% compared to last year. I didn't think when we were judging them, it seemed to be a lot of 3 inch plus onions in there. So it was actually when I was doing the numbers, I was kind of surprised, but I guess 2023 was even that much poorer than compared to 2024. But the five varieties here that had the highest percentage of jumbos, Ridgeline, and as you can see there, it's been 5 years, it's been in that top 5 for oversize. Copperstone, Milestone, Killington, and Bronstone from Herzera, ranging from 42 to basically 23% of the onions being over 3 inches in diameter. Looking at scores or the quality, again, that's based on shape and size, uniformity, skin thickness, skin attachment, the color of the skin, neck finish, an overall rating that we kind of do when we look at it. Trial average was 6.85, still kind of average, not quite into the good range, but a range from 7.8, which would be good to very good to good range, and 1 being kind of on the poor side at 5.54. But the varieties that had the best score, the best qualities, Skyline from Tacky at 7.83, Lodestar, Blazer, Safrane, Frontier, and Mountaineer are the ones that had the best qualities. And probably a lot of this I'm going to attribute to probably the skins being quite good there, neck finish and skin finish being quite on the better side. That usually is what bumps them up quite a bit. Looking at onion maggot damage, so trial average was, again, only 0.8% damage. And when we're doing that, we're taking the onion that we have, that we've taken out of the field, we're looking at it. We're not just only looking at an onion that's completely unmarketable, we're even looking for pinhole marks, the onion maggots at any type of feeding. So this year, the numbers were really, really low. I think two things are helping. The new seed treatments are actually really having a big effect on it because we've seen the incidence of onion maggot damage decrease over the last few years. But I think the second thing this year that helped a lot was the dry conditions of September. Probably, again, as I mentioned yesterday, when the onion maggot flies were laying their eggs in the latter part of the summer, 10 to 1, those eggs were probably getting dried up, or even the little maggots, once they start to hatch, are getting dried up. So I think that was a big factor in helping to reduce any type of damage. We found very little. Usually in the fall sample, the yield sample, we usually see a little bit of pinhole damage on the onions from the second or third generation feeding. And we saw like literally nothing this year. But anyhow, the varieties that had no onion maggot damage, Braddock, Catskill, Crockett, Frontier, Powell, and Killington. And then those that had the highest amount, still at a pretty decent rate, Horatios, Sumo, Lodestar, Y604, and Trailblazer. And again, like 2% basically. This one was a little bit spiked up high. So very, very, very welcome, all things considered. So adaptation, this year we had a few varieties in the adaptation trial. We had 5, if I'm not mistaken. They were seeded also on May the 6th. There were, 7 cultivars, and they were from 4 different companies. So again, these are varieties that the seed company might be just wanting to try out on Muck, see how it does on Muck. Might be something that they're soon getting ready to release on a more larger commercial scale. But the ones that had the best percent marketable, Iroka from Enzazetta at 94, Baggy, Tanat, and a numbered variety from Crookham. Looking at yield, Baggy from Enzazetta at 1282, Iroka 1000, Tenant, and Medusa. So sort of in that range. And score-wise quality, this is kind of also a typical thing when we're doing our evaluation, just to have you a bit of an idea. We take the sample out, we size it all into the categories, we do our counts, and then we kind of lay it out on the table like this. And then we're looking at skins, we look at neck finish, we look at firmness, we look at what type of shape it is, the uniformity. And we've been adding this baseball this year, and we found that that kind of helps give us an idea too on an overall scale. And you want something that's roughly a baseball size, hardball size. So we kind of aim for that. Anyway, and score quality-wise, Medusa was the best, and another one from Enzazetta, a number variety, and then Tanat. Then looking at the storage trial. So these are our 2023 onions that went into storage. We had 37 varieties. They were in for about 44 weeks in storage, ballpark. Looking at some of the highlights of the trial, the percent marketable was 31.5. They were terrible. Weight loss at 6.6. Sprouting was huge at almost 60%. It was a jump of over 20% compared to the 2022 ones. There was low amount of rot and soft found, but they were all basically breaking dormancy very early and well on the way in sprouting. Firmness was average. Fair amount of top and root sprouting was happening. But the ones that had the most marketable, the number of variety from Hazara, it's basically about 67%. Gunnison from Bejo at 64%. And you can kind of see there some of the sprouting that was occurring. We had a fair bit of the sprouting was well on its way. It wasn't just starting when we were doing our evaluations. LaSalle from Stokes, Traverse, again, sort of third year now that LaSalle's been in the highest percent marketable range when coming to the trials. And a number of variety from Hazara at 55 and Switchback from Seminova at about 54%. in that range. And you can kind of see there too, there's a significant amount of sprouting going on. So last year's storage trial was not the greatest. As far as ones that had the least amount of sprouting, because sprouting was such a concern, trial average again, almost 60%. A number of variety from Hazara at about 27%, Gunnison, Switchback, LaSalle, and Traverse. So again, LaSalle, highest in percent marketable, but also third year in a row that it has the lowest amount of sprouting after that period of time being held in storage. Ones that had the least amount of weight loss from when they were going to when we did the evaluation. Number of variety from Hazara at about 3.8% weight loss, Switchback, Mountaineer, another number of variety from Hazara, Gunnison, and LaSalle. And some of these names are a little more known to be a bit more of a storage onion. So, but the trial average was 6.6. So there wasn't a ton of weight loss, but yet the sprouting was a big concern in the trial. Firmness, how firm they were when they came out. Paricchio, a number of variety from Hazara, another number of variety from Hazara, Hamilton from Bejo, and Crockett, which has been in this top 5 for over 6 years now at 8. That was still quite hard and solid. Trial average was 6.6. So just kind of average, which would mean if you grabbed it, it has a bit of a cushion to it. It's not spongy, but it definitely has a bit of a cushion to it. Moving on to red onions. So our red onion trial, we seeded on May the 6th, and I reseeded it on May the 21st. So at the first trial, they were just nicely poking through, very, very early loop. I did a partner spray on it. We had a bit of moisture afterwards and some cool temperatures. And for whatever reason, probably application error here on my part, the trial really took a bad twist. A lot of burning and whatnot. And I decided to scrap it and start over again. So we lost a few weeks in there. The second time they came up beautiful and they were good. We had 13 cultivars. We pulled and topped them on September 27th. So we kind of left them as long as we possibly could to try to size up as much as possible. We did the evaluations on the 27th through the 29th of January. Just some points from the trial. Again, germination vigor was fair in the second seeding. Entire season growth was steady. Stemphylium leaf blight was moderate in there. They were probably had a slight advantage because they were a bit younger, not as old plants when Stemphylium was at its peak. Highest percentage of top die, a high percentage of tip dieback, that still affected them. Size was very disappointing, not surprising. They were seeded late, so we're not going to see the size that we wanted. And the other big thing we ran into with this was actually weed pressure was quite bad in the red onion trial. So the time we reseeded and things kind of got going, there was some good moisture at those points, and then the weed pressure was quite high. We ended up with low yields, again, being late seed, it's not surprising. There was a low amount of rot, because sometimes reds can be a little more notorious for having extra or rot issues. There was a low amount, very low number of jumbos, again, not surprising because they were seeded late. Stand counts were good. They were at almost 10. Fair neck finishes, even though they were late, they did mature decently, and they had pretty good skin quality when we did our evaluation. Some trial averages, again, about 9.6 onions per foot. The yield, which was surprising, it was up, but it was 943. Onion maggot damage, very low, about 0.5%. 98 days to maturity. Well, that was because we lost 3 weeks. That's probably what changed that a bit there. Firmness 7.6, pretty decently firm, and scores were in that average range. As far as percent marketable goes, trial average was 85.3. It ranged from 92 to 74. Half the trial was higher than 85%. Calls, there's a little bit difference there. We saw peewees, again, not all getting all fully matured. There was also a few doubles, and we saw the odd rotten onion in there. But the top 6, as far as percent marketable for that trial of those 13, SVNT 4677 from Seminis at 92.1. Bridget, is that named? Motley Red, thank you. A numbered variety from NZZ at 91.8. Comrade at 90.5. Red Marley from Stokes at 87.7, 88.7. Red Carpet and Red Wing from Bejo, finishing off of the top 6 out of the 13 as far as percent marketable goes for in the trial. As far as yield goes, trial average, again, kind of on the low side, just under 1,000. It increased by 100 from 23, which I was surprised to see that number also. It ranged from 1205 to 685. Approximately half the trial was above 900. And the top 6 as far as yield goes from the red onions, Motley Red from Seminis at 1205, number of variety from Ezeh at 1146, Red Marley and Red Garcia at about 1129 and 1065. Red Mountain and Red Eagle finishing off the top yielding out of those 13 varieties. Looking at jumbos, this number, I just did it because we have this slide. I kept it in. As I mentioned, there was literally no 3-inch onions out of that trial because they were too late. They just really didn't get a chance to fully mature. But there's a few varieties. I had a few that were in there. So trial average was 0.1%. We're in the 3-inch range. And Red Marley, the Motley Red, the Comrade, Red Garcia, all 0.5% to 0.2%. Looking at scores of the quality, again, same things that we look at with yellows, except we also do a score in here for interior color also. Trial average was 6.65, our average. It ranged from 7.3 to good to just average at 6. Top score, our score rating, Rebellion, Comrade, a number of variety from Ezeh, Red Eagle, and Red Carpet. And a couple of those you can see are repeats and being top scores from previous years. And the trial average at 6.65. Interior color, that's more important in the reds than it is on the yellows. But the ones that had the best rating for interior color, the top one was Comrade. It's the 3rd year that it's been in that top range. Barlow, a number of variety from Ezeh, and Motley Red from Seminis at 7. Trial average was 6.6. And we noticed this year that the interiors weren't quite as strong as what we have seen from before, probably more to do with a maturity issue than anything else again, just not quite having that same amount of time to get a full maturity out of it. So then we also did the red onions from 2023 season in a storage trial. There was 13 varieties. They were also stored for about the same amount of time as the yellow onions. As far as that trial averages, percent marketable was only 24%. Weight loss was 6.1, sprouting 68, low amount of rot and soft found. And firmness was average. A lot of top sprouts, but moderate root sprouting. So I have to say, we probably should have looked at this probably a month before we looked at the yellows because we were really stretching it out here. Reds aren't going to store quite as long as yellows do. So we were going a little bit that way. So that probably had a good effect on a reduced year. And sprouting, again, like the yellows, was the biggest concern going. Rot and that was not too bad. But the ones that had the best or held out the best overall as far as percent marketable, Red Marley and Nault at 37 and 36%. Comrade and SVNT 608. Is that one name, Bridget? Sorry. Red Garcia. Okay, there you go, Red Garcia. And again, same type as yesterday, you're kind of seeing names repeating themselves within the trials in different categories. Those that had the least amount of sprouting, and you can see here, trial average, we had sprouting at 68%. Red Marley, Nault, Comrade, and Red Garcia were the ones that had the least amount of sprouting going on. So the other ones were quite high. And weight loss was not bad at all. Trial average about 6, but very similar to what we saw in the yellows. But the ones that had the least, Comrade, Red Wing, 46 from Seminis, Bolero, and Red Marley, all sort of about 4% to about 5.5% weight loss. Very respectable. And as far as firmness, ones that held up the best, not quite the scores that we see in the yellows, but Red Carpet, number of variety from Ezeh, Ruby Ring, Bolero, and Red Wing coming out as the best one as far as firmness goes in the trial. And again, I'm flying through this, just giving a real quick highlight. Everything is in the Green Book. I hope you've taken some time to take one home more in depth. There's a lot more other evaluation notes and comments that we put down for both storage and evaluation samples. There's a whole little history of all the treatments that I put on the crops, all my sprays, all the fertilizers, explanation of some of the categories that you're looking there. There's more details about the ones that actually had cedars, all that type of detail. So please take a book home and peruse through and look at the information. And as yesterday, as I mentioned, we do have the webpage, the YouTube channel, Twitter, lots more information there, trying to get it out to you guys as quickly as possible. Take some time to look through those things, if you could, please. And of course, as yesterday too, special thanks to Tyler, who's helping out with running the trials. Our summer students, Maya and Adriana, that did a lot of the weeding, did a lot of the crop height measurements, other things like that out there to help us. Maya helped us with the seeding. Very much appreciated all their help and support to make the trials a success. And of course, as I'm last today and we're finishing off this year's Grower Information Days, just want to say thanks. Thanks from the Holland Marsh Horticulture Advisory Committee, which is basically Matt Shepard, Mary Ruth McDonald, and Shawn Janse. So the three of us would like to especially thank Kevin and Jeff and Tyler. They take care of the whole audio, visual, and online component of whatever. What are we doing? Are we feeding live or whatever? Through Zoom. Okay, so there you go. All that type of stuff that I'm more than happy to let them take care of. And then, of course, growers and sponsors. Growers, thanks for coming out and participating year after year. We appreciate that. We hope you get picked up some information. We are here to be of help as much as possible. Whenever you guys need it, come and see us. And basically our sponsors too for the door prizes and especially our lunches. It's all taken care of. And Alliance AgriTurf, BASF, Bayer, Corteva, Homes Agro, Stoke Seeds, Syngenta Canada, UAP Canada, Seedway, and FS Partners. So I would say go and say thank you to them, but I know most of them have packed up and left already. I guess we should really probably put this slide up first, the very first day, at the very first talk. So, but if you're in the rest of the season, you're dealing with these people, please make sure you say thank you for supporting the conference and allowing us to be able to do this year after year. So very much appreciated. And with that, I guess we'll conclude.